All right, welcome everybody. My name is Brian Little from Race Logic Chassis School. I've done chassis school for about 30 years. This year I was a good friend of mine that I watched race a lot. Most of you in the room probably heard of him, you know him, Dalvin Murray. Well, I happened to be in Oklahoma when he had a horrible crash. I was standing there, and to witness that, you know, as a dad, seeing a young kid, I really didn't think he was going to be alive when I walked over there. But he made it through it. Well, it just kind of inspired me. I'm like, you know what, everybody keyboard warriors got on the computer and wanted to talk about safety. You know, the cage should have done this, and this equipment should have done that. Well, nobody's ever done anything. Nobody's ever got together and let's try to find some solutions, you know. So I told myself, and I called Kate, and I said, hey, I want to do something. And so I knew she's having a car show, and it just all worked out. She was gracious enough to let us use the room to be able to do this. And I borrowed, begged, pleaded everybody I knew in my racing family to come and try to let's get information out. You know, it doesn't have to be I got the best product or whatever. I mean, there's people in the room here that I know has got great parts and seats and all that. But you know, let's talk about how to mount them, what to do. You know, the safety aspect of it. So I like I said, I do appreciate everybody coming. It means a lot to me personally, and hopefully we can get this out to thousands of racers. Like I told Chad when he came, if we can just save one guy's life, or one guy from getting burned, or one guy from getting hurt or concussion, then it was worth it to me. And so that's what we're going to try to do. It's nothing formal. Like I said, if you got a question, you have to talk to me on the microphone, okay? Ask away. Not everybody's going to be right, or you may have a different thought. The next guy, let's talk about it. I kind of got us a slideshow here we'll go over, and then there'll be some other stuff. People got slideshows. So we'll kind of start out. Ben Baker's helped me for years in my chassis school. He's going to kind of headline it because I told him I wasn't smart enough, but I knew he could. So he'll kind of headline it and get people to come up and talk. And you know, any of you guys, like I know Chris races a lot, so you know, if you got anything you want to add, any of the sections, be sure to add it. You know, that we can try to help. Okay, Ben, we'll get started with you.
All right. So like Brian said, this is really going to be pretty informal. You know, I'm by no means any expert on safety. I've been in motorsports since the mid '90s. I have seen some pretty bad accidents. I've seen a lot of cars at the tracks, and you wonder, how does that car even get on the racetrack? Or how does that driver even feel comfortable getting in that car? So I think a lot of the things that we'll talk about in here, hopefully will get out to the masses to have people kind of sit back and look at their cars and think, okay, what do I really need to do in case of an emergency? You know, how do I need to get out of the car? Practice getting in and out of the car. The guy I used to work with in a dirt late model, we actually did that. I mean, he was by no means a big guy, but that was one thing that he was always conscious of is, okay, how do I get out of the race car if I'm upside down? You know, we actually had some old cars where we mounted seats in them and turned them over with a fork truck. You know, try to practice getting out of the car. He had a young son, started racing go-karts and stuff like that when he was 5, had him in a stock car when he was 10 years old. You know, like a full-blown Camaro car. We had him in a full-blown late model 12 years old. Same deal with him. We had a lot of, at that time, there wasn't a lot of safety things that were available. You know, like the fire bottles were really rare to see in a car at that time. This was in 2000, 2001, 2002. So a lot of the fire bottle technology that we have today wasn't there. A lot of the seats that we have today weren't there by no means. So safety has definitely came a long ways, but it still needs a lot of help. But Brian's going to go through some slides here. I know we don't have a lot of fuel cell people in here, so please, if anybody has anything to interject towards it. I am not a big fuel cell person. I don't know just a ton about them. I just know things that I ran into from a mounting standpoint or what I see at the racetracks. So the fuel safe Jazz in this case, they're Superior. There's several different fuel cells out there. Very good companies. They've all learned things over the years to make these fuel cells safer. You know, something that I see at a racetrack a lot, and you know, this is probably not for many people in here, but you know, for the people out there at the racetrack. What was it, Matt? Probably in Tampa days when fuel safe got really, you know, that was probably mid '90s, late '90s. You know, one of the things that was like a big thing then was the fact that they had that flapper valve over the port of the fuel cells. You know, today that's a pretty standard thing to have or to see. Yet today, I will see a lot of racers take that spring, take it plumb out of there, take and bend it to where it's easier fuel cell funnel in to put fuel in it, things like that. You know, those things were put in place to help, you know, help safety, help in a rollover situation. So make sure that thing's in there, make sure it's, you know, we're doing what it's supposed to be doing. You know, if you have a question of whether or not it's doing what it's doing, fill the thing full of water, turn it upside down, make sure it's not leaking out. Same thing with the vents. You know, making sure that you have fuel lines or the vent line routed to where it can't siphon it out. I have seen those things siphon out on racetracks. I've seen them back in the day when we ran a lot of alcohol. You know, you fill the fuel cell pump full for a 50 lapper and weave the car, and it would actually siphon the fuel out on the racetrack while you was racing. So definitely check those things, make sure that all those check balls, everything is working the way it's supposed to be working.
Hey, Ben, I got something to add that I learned a few years ago, believe it or not, and I don't race, but the big fuel cap with a lid, you know, that's, you know, they were actually designed, they were for Bell helicopters. That's how they fueled helicopters.
Yeah.
Most people didn't know that, but the old metal lids with a D-ring or whatever on it, that's the one that the kid got burned up several years ago down in Texas, and I knew his father-in-law's horrible story, but he forgot to put the cap back on, and the flapper in there was wore out, and when he flipped over, all the fuel ran out on the ground. But that big D-ring, because his father-in-law had studied this, and that big D-ring cap I think made in Decal Bell, but it was designed for Bell helicopters. That's how they fueled helicopters. So terrible design, and I don't know that there's any of them left out there in the world, but man.
There's quite a few of them.
Yeah.
All the cars that were built in the 90s, I mean, all the cars, there's still a lot of them out there racing that.
If that flapper is not working.
They never even came with a flapper. The flapper didn't come out until the fuel safe or the ATLs came out with that smaller intake port. That's where the flapper came out.
That's,
yeah.
you do what, still selling?
Yeah.
Man, I'm telling you, yeah, they're cheap, but that's what, I mean, you got that big a hole, and you're upside down, and you know, it's running down underneath it, bad things can happen, so you need to make sure the safety's there.
The other thing I see with fuel cells a lot, you know, just working around cars at the track is just how these things are mounted. You know, you don't see too bad in like a late model or dirt modified more, I'm gonna call it like a store model frame, but you know, your hobby stocks, your pure stocks, some of the more home-built cars, you know, that fuel cell, if it's a 20-gallon fuel cell, there's 140 or 160 pounds, 140 pounds of weight swinging in there. That's a lot of weight if you think about it. And, you know, I've seen them mounted with 5/16 bolts. You know, it stood up on a spacer this tall. Well, you know, you get any kind of little accident, that thing's not going to stay. So you know, just pay attention to a lot of those different things. A lot of this is pretty much common sense, but people just don't sit back and look at that when they're looking at the car.
I wanted to bring up on your vent line on the fuel cell, excellent point, you can loop it. Or the other thing being, make sure that the line is below the fuel cell and properly secured. Oftentimes I've seen the vent line just laying on top of the fuel cell. So if your tip over valve isn't working as it should, and you get flipped, all of a sudden that fuel's now all rushing out the vent hole.
Yeah, I like to take them basically straight out of the vent, and even if I can make a loop up and then all the way down, but make it where the filter is below the fuel cell. That seems to always work good. Also, if you run it that direction too, when you wash the car, you don't have to worry about getting water up in that line or water trapped in there. So there's a lot of benefits to doing that, getting a line like that. Any other questions on sales or statements or?
And I don't need a mic probably, but just.
Oh, well, you got to.
If you can mention just high grade bolts.
Yeah, high grade bolts. You know, don't go whatever you can get, Harbor Freight or whatever, and get in there. Get some grade 8 bolts. You know, I don't know exactly what they're recommending as far as bolt sizes, but for me, I would think the 1/2 inch diameter would be the smallest that I would want it really. So.
As well as the quality, as you mentioned, those are both excellent. Do not buy the cheap eBay, Amazon aluminum fuel cells. They are very cheap. They do not work very well. You're looking for something with an internal bladder, plastic bladder, metal case, something along those lines. The cheap aluminum cells that you can find online for like $100, they do not have anything internal. It's just aluminum box that's been welded together. So with the bouncing around, the welds start ripping, and now your car is full of fuel. So Do not buy those.
Yeah, I think most of the, more name brand heard of fuel cells in our industry, I mean, they're good cells, it's just a matter of how you use them. Anything else on that? Fuel lines, carburetor, again, Matt, you might even interject on some of this, but, the fuel lines, basically routing those things to where you can keep them away from heat. Think about if something gets on fire, is that fuel line the first thing that's going to catch on fire? If you chuck a rods out of a motor or something like that, have a big fireball, is the fuel line the first thing that's going to hit? If you get in a wreck, thinking about most cars in our world, if we're looking at like a right front impact, does that, if the frame moves, does it get a fuel line pinched or cut? So just think, try to think outside the box. Hopefully you never have to be in that situation, but just think of things that can happen that's out of the ordinary, and make sure those fuel lines aren't in the way of that. If you got anything else?
Also checking, a lot of people use push lock fittings on that, just a inexpensive way to get the car done, but, checking those fittings, if that's what you do, use,
Yeah.
making sure that, those do tend to wear, come loose, and you fray the hose or whatever, they can leak under pressure, so just keeping a good check on those.
Yeah. Yeah, as far as lines like that, I've never been a huge push lock fan unless it's a suction line. If it's a pressure line, even a line that's got 15, 20 times the pressure on it, I want to have a line that's really made for pressures. I know a lot of people use push locks and they have no issues with them. Like I say, it's a bit of a maintenance deal, but if you can, getting lines made today is no big deal really. In the grand scheme of things, it's not the most expensive part of the car by no means, but if it's going to be under pressure, I try to stay away from push locks. Carburetors, there's been some great safety things put in place for carburetors over the years, between rollover valves, a lot of the Super Bowl stuff. A lot of that stuff has came from a performance aspect, but at the same time, a lot of those carburetor builders have done a great job of thinking about safety compared to what it was 20 years ago. So definitely, look at carburetors that have some of that technology with them. Is hey, if I'm upside down, is this thing going to drain the balls out? Is it, what all is going to happen with this thing in a wreck? So, some things you can do in the older style radiator or older style carburetors is looping the hose between the breather vents, things like that, just to capture that fuel if you get upside down.
Yeah. Hey, just the other thing on the carburetor is we've seen a lot in the last couple of years. At least for me, it's a lot because one is a lot, but significantly more than that. But where that carburetor arm comes back and hits that throttle stop and it's a bolt there. Anytime I see that, I'm recommending to weld a washer on that to make the outside diameter that smooth, because those quick disconnect throttle arms will get hooked on the side of that bolt and keep that throttle wide open. And I've personally seen 4 incidents where that's happened, and it's went wide open and it destroyed cars, and luckily they walked away. But literally take 5 minutes just to make sure this thing's lined up right and it has hitting a flat surface, and make the surface larger if you need to.
Yeah, definitely throttle stops are something very important. A lot of people do overlook that. I like the throttle stop like you're talking about there. I also like the one that you can put, in the driver's compartment to where the throttle pedal can't over travel as well. One thing actually I have ran into from a maintenance standpoint, I have seen the butterflies come loose on cross shafts. I have seen base plates come loose on the Venturas. So that's something weekly or monthly I would take apart, make sure none of that stuff's loose, moving around, because yeah, you might even lose a screw and drop it down through an engine, and that's really bad. But if you get one of those cross shafts that comes loose, or a butterfly comes loose and hangs that thing wide open, that's going to be even worse. So definitely, from a maintenance standpoint, you can look at those things on the carburetor. I don't think they've ever had that happen or not, but yeah. So, chassis construction, so there's a lot of information. We've got two very good, car builders here that have brought some presentations to show on chassis construction, placement of tubes, materials, welding practices, and things like that. So I'm gonna let those guys take over a lot of that. Talk about it. So we got Spencer Hart and Brandon Norman. Yeah, just going up and talk about those things.
After Dallin's wreck, I got with Kyle Brown that owns Harris, and this is their 2025 design. I'm not a chassis guy, but from what everybody said, it's a lot better, more up-to-date design. So they just wanted me to show it that they made a lot of improvements after his wreck. So we'll get Spencer up next. And I'll let him kind of tell who he is and what he does, and he can brag on himself.
If you want to come up here, it's fine too.
I'm trying to make sure my mouse and stuff are.
Okay.
So I can click through the slides. All right, I'm not much of a public speaker, and I appreciate everybody being here. I've never really had to do this with a mic in my hand. My name's Spencer Hart. I'm a Sharp Manufacturing and Sharp Engineering. This is kind of spawned off of some childhood hobbies and so forth. I swore I was done with dirt track racing when I got 18 and said I was going to college and do something different and keep my nails clean. But things changed. I circled back to it. I had a son. And then when he was 3 years old, he was making circles around a pine tree in the yard, so I knew it was genetic at that point. Cash, we kind of tested some of that as you guys in the room here. But I've got a master's degree in applied engineering. I did an undergraduate degree in mechanical engineering at Georgetown University. And I had some help with this presentation from E.B. Smith. He's a manufacturing engineer at GSU, former student of mine. Basically, most of you probably don't know me, maybe not even see my face, but I've got 12 years really directly involved in the industry. And then I kind of go into sort of what we do from the chassis side of the house. Thank you, it's not really sensitive. But the two companies I have, Sharp Engineering, we kind of focus on innovative solutions for the industry. That can be industrial or race car related. And then Sharp Manufacturing is the fabrication side of that, so we kind of divided those two entities a few years ago. And we do a lot of white label chassis production for different builders, across the thing. So, you may not know we built it, but several of the cars that are all over these tracks today were manufactured in our shop. All of the CNC tubing cutting, the plasma cutters, JD squared, all that type of stuff that came out. I'm not taking credit for it, but in 2011, we actually had one that was built in my shop, and that's sped up production. So we're a fairly small crew, but the amount of volume that we can push out is pretty substantial. So, sort of an outline of what I've got. I don't want this to be a college lecture, and I'm trying to refrain from that. But there's a lot of material, there's a lot of information, and I felt compelled to come up here and kind of speak to what I knew, what I've been shown as best practices. Don't take anything that I'm saying as concrete or you must do. I may be wrong. I don't profess to be the most intelligent person in the room or in the sport for that matter. But stuff that I've seen, stuff that I'm trying to correct, things that I'm, working on. My son's 11 years old now. He too started racing cars when he was 3. So that story that Ben was telling about that guy they were working with kind of resonated. I mean, 3, now he's 11, got 602, runs one of our cars. We started building the Sharp Mini late model in 2016. Sort of what really got me back into the sport. That's a scaled down dirt version. I was too poor to race the big stuff, so I was trying to find a cheap way to get back and go fast. But I'm not giving you a sales pitch on that. Y'all can look it up if you want to. But the main outline for this presentation was, what is a space frame chassis? And unfortunately, I got to assume everybody in the room is at the same level of knowledge on it because one of these presentations for you guys, it's has a lot to do with the viewers that are here online now and the people that are going to play this thing over and over. I assume that a lot of people don't want to get here because they don't want to admit they don't know what they don't know. And so it's an embarrassing thing or whatever, I don't care. But if one person takes something away from this presentation and applies it, I feel like I've done my due diligence on that. But we'll talk about material selection, welding techniques, load path, structural triangulation, common issues, safety regulations and some discussion points, and we'll kind of open up, for a conclusion on that. But space frame chassis, is primarily what we're all racing now in the dirt scene. It's just a triangular network of 3D tubes. So all we're trying to do is brace for impact. And we're one of the only racing, bodies that doesn't have a centralized safety organization that sort of mandates what we need to do and how we need to do it. So, as I go through the presentation, start, kind of look at what we've got. What you see there, now, clearly that's not a dirt track car. That's an exaggeration of triangulation, but that is a monster truck chassis. So the number of bars that are going crisscross, he talks about load pass. These things are designed to be jumped 20 feet in the air and land on the roof and the driver survive. Key design principles, triangulations, node alignment, stiffness versus weight, and serviceability. Kind of what's going into these chassis. So node alignment, and I love my, and actually I've got some good examples of it, but it's just really, if I have two bars coming, well, that one doesn't work right. I thought we'd fix that, but I'm just messing around. There's a couple of them. I got one right there too. My Josh Bishop is in the room, and there's one right in front of him. It's green. He might be trying to watch mine not work. If it doesn't work, we'll just talk through it. Okay, so just say I've got a upper halo, and I've got my down bar that's coming in and welding in that way. And if I put some sort of brace in it, if I put it in here, this point when I say node, that's what I'm referring to, is where those 2 points come together on the bend. I've got some good examples of that. The relationship of where the bar is to the node, so coming up with a halo support bar to this point right here, you're not nodal. Several sanctioning bodies regulate how far that point can be from the node. We don't have anything like that in the code industry, but we'll get there. Triangulation, I forgot I put this slide in here, guys, sorry. That's exactly what I'm talking about. So, this picture is from Formula SAE. Now, Formula SAE is a student racing organization across pretty much the entire world, where these students design and build chassis and come together and compete annually. Some people have been involved in it here. I was a faculty advisor of that program at the university. So I had their rule book for a student organization car is 247 pages long. I would say it's ridiculous, but it was when I was having to deal with the rules. But in hindsight, it was it's not. And feel free, guys. Anybody who wants to chime in, I like to talk, but I don't want this thing to be monotonous either. So chime in, grab a mic, whatever. Tell me to shut up. Then you also have the other side of the SAE world, and that's by SAE, where they design chassis for like an off-road version of the same concept. So you've got your guys that want to jump, play in the mud, you got your guys that want to go fast around a little road course. This is a simulation that was done by a college team, by SAE team, which we all had to do, but it just shows you the sort of a finite element analysis of what the chassis was going to do in impact. So what's simulated here is a frontal impact on the front, what kind of deformation you would get in that scenario, and a side impact from the side to see what kind of side deflection was there. I don't know how many builders in the industry are using FEA to validate their chassis designs. To any kind of capacity. I'm sure some of the big ones are. But I mean, the dirt scene has been an evolutionary product, from literally cutting laps in somebody's backyard to what it is today. But there are tools and technology out there like ANSYS, and even SolidWorks has built-in simulations if you're not familiar with it. So if you're designing in SolidWorks, which some of these newer, younger builders may be doing, you can run simulations on that, and they can even, you probably get some organizations to even sponsor a CETA, because you're doing good for the racing community by doing that. Load pass, when I'm talking about load pass, we're talking about forces that are entering the chassis, going to a location, and then where they're going from that point. So frontal impact or whatever, if in the FBA side of the house, I can tell you what bar is being loaded and how it's being loaded. FBA can predict weak points. So obviously we need a physical inspection, etc. If you hear me say in a little bit talking about forces and vectors, what a lot of people don't understand is just because you got a bar braced one way, you need to think about the degrees of freedom that node has and make sure it's being supported from other directions. I've seen several chassis that have some triangulation in it and they appear to be good, but if they took a hit or rolled a different direction, the entire cage would collapse. You know, so there may be a right side bias for the triangulation, a left side bias for the triangulation. But anytime there's an impact, there's a force vector that goes into that. And, you know, clear illustration of a dog, you know, if I'm pulling a dog's leash, I've got an upward and a backward motion. So that just kind of shows pass. This is a chassis that we were working on with a guy. We were trying to optimize, and, you know, and I just took it through some squiggly lines on it so you can see. But basically, if I took an impact on the front left of that halo, I'm going to have forces going down the A-pillar, and vice versa. So there's forces being transferred anywhere in the chassis. What? You get the frame up here? Okay. So the forces are, when you look close to it.
Yeah, get over there.
So if I get a hit, usually I have a mouse pointer or something, but if I get a hit in this corner here, I'll have forces coming down this A-pillar. They're being transferred into the, you know, this brace here. And I did this intentionally. I put this up here so you can see that this point right here, it doesn't have a direct load path into the bar beneath it. I'll talk about that in a second, but you see this a lot in the dirt industry. Like, you can go across chassis brands. I don't care who you're looking at, what brand you're looking at. Some things I want you to look at when you're buying a car, inspecting a car, talking to a builder, or even considering building one yourself, is think about the load path. Where the forces are going in this chassis in the event of a rollover, in the event of a hit. You know, what type of scenario you know, would happen. You know, if I landed here, what's keeping this point from collapsing down? Well, in this particular chassis, it's, you know, the bending resistance of this bar, and then the brace here is supposed to hold up that corner, right? You're talking 2,400 to 3,400 pound vehicle landing on its roof. The forces that go into that are fairly substantial, even in a rollover scenario. So when the force goes here, it's transferred into here, and now the only thing holding that point up is the bending resistance of this section of tube right here. Now, I'll put the shadow on it, so I'm sorry. Here we go. So in reality, that bar here, this door brace, should be in line with that, so that the force can continue to come down the chassis, come down here, and eventually get down to the base. So the more direct the load path is, the stronger it will be in that direction. You know, and so you can go around the car and just kind of visualize, think about the types of impacts you're going to experience. You know, I'm not a pessimist by any means, but, you know, think about worst case scenario in the event of a crash. You know, where's the force? You know, like if I'm laying on my side, I roll over and I'm on the side of the car. What's my points of egress? What's being blocked, you know, by these braces? Can we do something different with the bracing to, you know, make egress easier? And if I'm standing on my side, Cash brought it up last night, what are we doing for underbody bracing structure? I can get the bottom of the
That was something I was fixing to talk about. You know, one of the things that, as you're looking at car construction, you know, look at injuries of things that you know about. So Kevin Swindell is a perfect example. You know, sprint cars are fairly safe. They're designed to be rolled over and over and over and over. No one ever designed one or thought about getting that, you know, hit the bottom. And that's what hurt Kevin, was he turned over and then got hit in the bottom. And that's what did his damage to his spine and things like that. And it made some changes in the sprint car world from that wreck.
It's extremely difficult to brace for a violent car impact. None of us, you know, want to be hit laying on our side of the car. We all get that. We also all understand that racing is a dangerous sport, and there's, you know, you can go to an extreme with this stuff. But what I'm just trying to point out things to think about and look at sort of the best practices to use. You know, if there's something you can do that doesn't jeopardize, it can jeopardize a little bit, but isn't hindering your, you know, something. It's just one extra bar. What is that one extra bar? Every car out there at the racetrack right now has lead on some capacity. You know, we keep making these cars lighter and lighter and lighter, you know, for the sheer purpose of moving that lead around and having, you know, the ability to get more rear weight bias or whatever to put it where we want it. It's what we're telling ourselves. But I think we're doing that at a sacrifice to safety. I got a couple of just one changes at high profile failures. This picture that's on the screen here, we were racing Talladega, my son was running 602 a day, and he got down, he's like, Dad, I really want to go to the museum. And I'm like, okay. And it's like, man, we gotta get home, it's cold, you know, Talladega wore us out, we sucked. But, you know, we got better as the night went on. But so I took it to the museum. I never walked through that museum, and I encourage everybody here or anybody that's in the area of Talladega to walk through that museum. Because firsthand, you can see the evolution of the race car chassis. I've got 50 50 or 100 pictures, you know, from, you know, like A-mods to, you know, vintage modifieds, et cetera, that go all the way up. And then I got to this room and I saw this particular chassis. So as I was there, I knew I had this presentation coming up, and I was like, man, I said, this is perfect. I can write off this business expense, A, and B, I can go through and get some good examples of, you know, sort of the evolution. We don't have all day for me to stand up here and show you pictures and talk about things. But when I got to this, the hair stood on my arm, right? If you don't know what this is Michael Waltrip's 1990 crash where you get the opening on the wall. Like, nobody wants to do that. Nobody would have predicted that. We can't even design a car to withstand that type of impact. But he hit that opening, and it shredded this car. And the fact that this, you know, he walked away from it is, you know, an act of God or whatever your beliefs are, or a miracle, whatever. But he he walked away from this crash. The seat, and I had to stand up my arm now. The seat is literally hanging out on the left side of the car. You know, my biggest fear in working in this industry is someone else's life. Like, you know, if I go to a racetrack and I've got 15 cars, like in any late model class, every car that's out there, I manufacture. Please second, please. And you see 17 of those rolling racetrack, and it's just like seeing your kid walk out to a baseball field or you're jumping into some high-risk activity. You know, when we first started, I mean, literally the hair was stand up every time, and it wasn't because I was excited they were on the racetrack or whatever. It was sheer fear for me because I knew at that point I had 17 people's lives in my hands. So it was extremely, it took me a while to kind of get used to that. But this right here resonated in me significantly. And it goes into a lot of what I'm going to talk about in terms of like heat affected zones, what kind of failures, what we're looking at for tubing thicknesses, were the load paths correct. It's a very, like I said, it was a very emotional interaction with this actual car. So I encourage all of you to go, if you're a builder or anything of that nature, go look at it. You can see the history.
Yeah, I just wanted to point out that that's actually Mike Marvin's car, and that got hit twice.
Did it?
Yeah, so it hit the butt end of the wall, and as it come across the racetrack, Johnny saw it hit him, and it knocked the front end. So it was running by the time it got to turn 3.
That's insane. And they got a video showing the incident, the wreck, and I mean, it's all on YouTube. You can check it out. But I stood there and I watched that thing play through about 4 times. Just trying to see like what the impact was, how it was hit, and then looking at sort of the back end of it, that lap he's talking about. He said, yeah, it's 6
Was the big thing where it tore all that stuff off the front after it got, it got loaded, weakened out the wall.
The wall ripped it, it ripped it up, and then it laid there, and then he kind of drove through, on the second hit. So that's the thing. All right, I'm not trying to get too scientific on everybody here. I don't really want to, but I'm going to quickly go through material selection, and I'll probably give this presentation to Brian and make it publicly available. So if anybody wants to go through, I wanted to print out some copies, but the color printer was giving me a hard fit. They didn't look that good black and white. Anybody wants to go through and look at some of this stuff in greater detail, we'll make it available for download somewhere. I'll put it on one of my websites or something. But real quick, the kind of materials for roll cage construction in here. You've got ERW, DOM, 4130, 4140, different types of material, different production techniques, etc. But get some engagement from them. You can chime in. We don't know who's got the mic at this point, but 4130 and 4140. Anybody here know what the difference between those two materials are?
Was it carbon contents one of them?
Yep.
That's the biggest one I know about.
Well, I mean, why is carbon content in tubing important and an important decision in what we're doing, and why we're doing it? Yeah, it is. Carbon content controls basically like heat treatability primarily. So a lot of your materials and steel, the higher the carbon content, the easier it is to heat treat. Why it's important in roll cage construction, and it's an important consideration, is because every time you weld something, you're putting heat into it. So you've got a heat affected zone. So when I go back and look at some of these pictures, you'll see a heat affected zone outside the weld, roughly 1 inch, where you're seeing the color shift or any kind of discoloration. Well, what happens there, even though you're welding in this cooling, you're essentially air quenching the material. So when you quench something, it becomes harder. So you think about somebody who manufactures nuts, blacksmith. They heat something up cherry red, you see them dip it on oil and forge it or whatever. They dip it on oil. What they're doing is they're quenching it. They're controlling the cooling rate. And what that's doing is controlling the crystalline structure inside the material that determines the hardness and how brittle it becomes. So what happens when we weld these things, especially when we weld 4130 and 4140 with a MIG welder, is we have very high heat input into the weld pool, and then which effectively gets that tubing very hot, and then we air quench it, which cools it fairly quick, and then we change the grain structure of the material. We're physically altering how the material performs from a, from a material standpoint right at the point of weld. So if we go back and look at that water press, or we go back and look at any wreck, or we go back and look at all the race cars that you guys are having to inspect every week, and we're checking them for cracks. Where are they cracking? They're cracking right at the edge of the weld. Every one of them, I don't care. I haven't seen a tube yet that's cracked dead in the center. It doesn't happen. And the reason why that's the case is because you're changing the grain structure of the material, creating a stress concentration. So technically, if you look at aerospace use of 4130 and 4140, when they were building fuselages and stuff for airplanes out of this thing, they were either brazing it together at a lower temperature, or they were running it through a heat treatment process, which was stress relieving that chassis, making that joint much safer and much stronger. I don't know, and I may be wrong, I don't know of too many chassis manufacturers that are using chromoly that are heat treating their chassis. Anybody tried it?
Maybe in the sprint car world at one time, but it's pretty slow.
I don't know. I mean, I truly don't know. That's, I mean,
The sprint car world still today uses chrome all a ton, but they are 100% TIG welded, not MIG welded,
a much better way to do it, because you control the heat input with TIG welding. So chassis builders building chassis using 4130 tubing, MIG welding it with an E70 wire, whatever wire they had stuck in their welder, you're really shooting yourself in the foot when it comes to strength, longevity, and fatigue life of that chassis.
Yeah, so like late 80s, early 90s, when chromoly was really big, like in dirt late models, like Bullet, for instance, they used it for years. It was all MIG welding, and most of those cars were 1 year done car, or you had to spend a couple hours every week welding everything back together. I mean, that's just how they work.
All because of the carbon content. So I circled that to highlight that. I got some specs in here, like, pros, cons on, why we use ERW, when we use DOM, what's better, that sort of thing. And you've got DOCOL and other materials out there being, brought into the industry. I don't know if DOCOL's gotten any better, and somebody in the room may be able to speak to it, but I know in the early stages of this introduction, it was very inconsistent in its carbon content and seam quality, and we were running into issues with the seam splitting in high stress situations. Now, DOCOL R8 by, from a market standpoint, is supposed to provide chromoly-like material properties and strength and stiffness with the ductility of your DOM or ERW.
From what I've seen, DOCOL was basically a fad. It went just about as fast as it came because of those inconsistencies in the cars.
Like I said, I really don't know. I can't really speak to it. And some people are saying that certain manufacturers are still using it heavily, and that's why their product is inconsistent. I don't. But the two main things you're going to see, in pretty much all your entry-level divisions, or what should be entry-level divisions now, are ERW and DOM primarily. You're not seeing a whole lot of chromoly being rolled into the street stock and the factory stock scene, for the sheer cost of the material. And if it is being rolled in, they probably don't know why they're using it. It's just being brought in there because it's better. My preference in all of this stuff is that, and this is me personally, people may have other opinions, but I tend to use more DOM of a, thicker than normal wall thickness, just because of we've done calculations on what it is. And we're not trying to sacrifice safety for weight gain, not when you have to add 2,000 pounds of lead. So DOM stands for drawn over mandrel. Basically, it's made in a very similar process as your ERW. So it still has a seam in it, but it's drawn through a mandrel. And what's happening when they draw it through that mandrel is it's compacting the grain structure. So when it compacts the grain structure, when it goes to that mandrel, it makes the material stiffer, it makes it stronger, and it makes it a lot more consistent. ERW is basically undrawn over manual DOM. Most of the time, the carbon contents are very similar. You know, DOM has a little bit more carbon in it, but it's got a seam, and that seam can fail. It's used heavily in the racing scene. I still use it in some of our cars, but we tend to put the ERW in non-critical areas where we're trying to introduce flex. You know, that would be a whole nother conversation, but we want to introduce areas for the car to fail. So in the event of an impact, we have essentially a crumple zone, somewhere to absorb the energy. But for the main primary structure, anybody who's building a roll cage for, let's say, I don't know, a 2,000 pound or heavier car, I would highly suggest using DOM for the core, and really looking hard at your load paths. We spent way more time on that slide than I intended to, sorry. And this is something that I've seen more frequently than I would like to admit. You got guys running out to Lowe's grabbing sticks of black iron pipe, going to grab a Bible Jack bender from Arbor Freight. I'm not picking on anybody. I mean, it is what it is. But for the price of a cage now, you know, a pre-bent cage for whatever it is you're racing, that seems like that should be a thing of the past, but it's still happening. Black iron pipe, Schedule 45, quick rundown, designed to transfer fluid, right? It's very inconsistent in carbon content. The weld seam was not designed to take any kind of a structural load. It's basically made out of, most of it's made out of recycled scrap metal. So there is no control in that material. Using it in a race car is absolutely ludicrous. So I'll leave it at that. If you want to read more about black iron pipe and why we don't need to use it in a race car, like I said, you can check out my site later. I got a lot of information on it. Welding techniques. We talked about heat effective zone. I brought this picture in here just so you could see what, if you didn't know what a heat effective zone was, or you're somebody at home on social media or whatever. Heat effective zone is, you see the area of discoloration where the color ended. That's the area that got affected by the heat. There's certain things in metallurgy where you're talking about critical temperatures and that sort of thing. You know, if you want to explore that any deeper in the grain structures, feel free to jump on, you know, YouTube or wherever and dig into that. Filling materials, making sure you're matching your filling material to whatever material you're welding is another key important. Don't just grab the welder and assume that it's got the appropriate filling material in it for the application. Running out to Lowe's and grabbing some flux core wire and sitting going home and calling yourself a race car fabricator, you probably should hire somebody to come in and weld it for you. Clearly there's somebody that can weld with inner gas or something like that that can produce a better quality weld for the application. And I think there's a couple of other presenters in here that have some really good pictures of kind of what not to do. We'll get to that. And one or two of them, the other additional presenters are talking about sport compacts specifically, so I won't spend a ton of time here. I'll just point out a couple of things that I don't like about sport compacts. And one of them, and I'll have to walk down here and get a stick or something to point the wall. So the sport compacts, this is an EG patch, 1995, and it's a very predominant platform in the front wheel drive scene. They case swap these things and they actually do pretty well due to their wheelbase. But from the factory, this is the factory headrest. Well, right now, that's where you technically want the driver's head. So when you're mounting the seat in these things, you want to get the seat as far back as you can to beat failure. But when you do that, you lose reach to the steering wheel, you lose reach to the pedals, and relocating the pedals in one of those cars is not the easiest task if you're trying to use OEM pedals. So, a lot of times we'll make a false set of pedals and connect it to the additional pedals, to bring the driver back, whatever the case may be. But I've built a few of these and then said I never want to build another, just because I don't like the inherent distance here. So you've got a substantial amount of distance between this point and where your roll hoop would be, which makes this angle here very shallow. That shallow angle is often supported from a bar here. I've got a picture coming up that will show you that won't work. And in an ideal scenario, you can support from here down to the bottom of the car, which is what these little green lines are for. But when you do that, you really limit your egress window there, which makes it a very difficult platform to build a safe cage in. And he's got a mic that he can chime in and add to it.
I just wanted to jump into yours because you put a lot more time into your presentation than I did. But he's exactly right. A lot of guys want this bar way up against the window. And if you're actually sitting inside of the car, It is nicer because you almost don't see that roll cage there. The guys that I've dealt with in the past that I run into this situation, that's exactly what they're looking for. I want that bar as far up in the corner and hidden as possible. The problem is, just like he mentioned, you're putting so much angle into this bar and it's so long. In a sense, the shorter that bar is, the stronger it is. If you span that out 40 inches or however, 30 inches, whatever that is, you have to move that back further to help support that corner. If you don't, you go halfway. We've got pictures of what halfway gets you. So you're going to have something in your way, whether it's what you want or not. Whether it's hiding it all the way up in the A-pillar, bringing it further forward and less angle, or additionally, your corner support.
So here's an example of a collapse on a cage that doesn't have diagonal bracing we were just looking at. So you roll the car over, you land it there, you get the bowing in the center of the cage with no support. You know, the roof's now on the driver's head. Hopefully he was okay. We were talking earlier about, you know, random ways to get impacted. This car had barrel rolled down some straightaway, and you had another car came in and clobbered it straight in the top of the head. So this gets me into something else I didn't really get a chance to talk about, but it's the head type clearance. So if you're building a car, especially in the S4 compact world, make sure your seat position and your roll cage placement, all that, you know, you've got head clearance. Especially if you're not, I mean, I don't know who would run a full canopy at this point, but you know, if you've got a anti-intrusion bar on the left side, make sure that you've got, you know, all the room you need to keep your head from impacting that, because that impact to that bar to the side is where 90% of your concussions are coming from. This, I had no idea where this came from, but I was looking at roll cages. This guy's literally hanging halfway out of the car as it's barrel roll. I don't know if he's okay. I don't know this guy. I don't know anything about this picture. I just saw it, and it was another one of those emotional triggers for me. Like, okay, what happened? Why did this happen? Who didn't inspect this car before it went on the racetrack? Like, what are we doing? That is his glove. I didn't see that until just now. That is 100% the man's glove. You know, come on. That's please have them on. Another thing that we see in the sport compact scene is very poor integration to the core structure. You know, we built race cars on Metro Monte Carlos, Camaro nose clips. We're doing, you know, subframe connectors. We were doing all kinds of stuff with these big cars back in the day because they were weighted a ton. You get in the sport compact scene and the newer model stuff, you're dealing with unibody cars. So any car that I had ever built that was a sport compact, I went through and basically gutted the lower rocker panel and then inserted a 2x3 tube there and then built my cage off of that tube. So there was a 2x3 piece of spur stock that went from the back of the car pretty much all the way to the front to try to give me something stronger to tie into. You're dealing with foreign sheet metal that's paper thin, and this guy here, you know, he was following, you know, the industry recommendation of a low distribution patch on the bottom of the floor pan. We can all see what happened to that roll cage when it punched through the bottom of the car over in, my mouse is working on here, but over in that area. So that's not what we're looking for. So gusseted connections, tying in subframe connectors and welding into rocker panels are key. You see a lot of this stuff here. This is really, you know, these are just some examples of ways to tie in if you're not doing a full subframe connector or a rocker, you know, inlay. Boxing out an entire corner where you're attaching to the unibody in multiple angles, multiple locations. Even tying into, you know, the A-pillars over here if you're trying to use A-pillar. I don't want to put that picture on there. Me personally, I'm not a huge fan of that because you're putting a whole lot of heat into the center of that bar. Like, I don't care if that A-pillar bends on a rollover. Right? But you see a lot of stuff like that trying to tie in veteran locations. So, you know, if you did have, you know, poor tie-ins at the bottom, all of those gusseted, you know, punched hole tie-ins, I mean, I guess that's, you're at least getting a bite on the car a little bit. Common issues in chrome alloy welds, we talked about this, you know, improper heat controls, stress relief. fatigue micro cracks. And that's why I keep looking back over the mouse is going nuts. And we got a seat expert in here, so I'll, feel free to chime in. I see a lot of improperly mounted seats in seat belts, especially in the sport compact scene and the factory stock sort of division. Seat belt redirection around structural members is a problem. Seat belt redirection around your shoulders is a problem. These rules are copied straight out of that collegiate competition rule book that I was telling you about. So, in the rules, it gives us an inclination angle from horizontal, on how far down to drop the seat belts, how high they could be, and then sort of our belt position for our lap belt, and then the belt position for the anti-submarine belt. It's important that you follow that and you work with the belt manufacturer recommendations on how to best secure the belts to your car. Putting belts attaching belts to a roll cage in single shear. If you don't know what single shear is, where I've got one tab on one side and a bolt up flat on the other side, I've got one shear plane on that bolt. That's less than ideal, but it's pretty much a dirt track standard. But we'll tab on, we'll bolt the seat belt to it, and we go racing. Putting that as a second tab there, which costs you another $1.25, doubles the shear stress, the shear area on that bolt. Because if you do that, now we're truly trying to shear that bolt. But if you got a single shear tab, you're not only trying to shear that bolt, it's also got a bending moment on that bolt. So it's trying to bend, it'll break the bolt and shear the bolt with single shear tabs. And so some of your belt manufacturers, they sell double shear tabs. It's going to be welcome to cheap investment. Follow the user's recommendation, the belt manufacturer recommendation in terms of bolt size, and look for sharp edges in the seat openings, just to make sure that your belts aren't chafing or anything. If you start seeing chafing on a belt, get with the manufacturer, get it replaced. Again, that's cheap safety stuff, it's bolting stuff. Anybody, belt manufacturers, want to add anything to seat manufacturers, want to add anything to the belt? I may be 100% wrong.
I will speak to our part. I think your general guidelines are in line. I know what that comes from. It comes from the competition for the
essay. There's some just straight out essay.
for the collegiate stuff.
That's straight out essay. It's nothing. There's no other sanctioning body on that. And I'm sure like NASA and SCCA and others have different sets of regulations on where they're going. But redirecting of belts was the main thing I was trying to get. I see guys that'll basically run your shoulder belts all the way down to the floor and put them on there with a fender washer and run them up and redirect them over the seat. And that's unacceptable. I'm picking on a product here. I don't know who made it. I really don't care. I don't like it. I'm just going to state my opinion on that. That Moroso seat bracket that's got a single bolt, the single pole coming into the back of it to a tab. Oh, and the picture up here, whatever shop this was, they put this seat bracket on. I don't like it. The reason I don't like it is if you get any kind of major hard impact, forward or backwards, and that comes loose, where is it going? Yeah. You're getting stabbed in the back with something. And so, why they were selling those? I don't know. I can see somebody doing it like in the top picture in the backyard, not knowing any better. But for a manufacturer to be offering that as a solution to seat mounting seems a little bit out of line.
So some of that, even looking at your rear clip structure of the car. So the first year they had wore the all finals at Charlotte. I was there with Don O'Neill, and he had a pretty bad flip and landed on the tail section straight up and down. And the way the car was constructed, there was a bar that came in behind the seat, and then the rear frame rail went back to the back, and there was no angle bracing where those two intersected. So it shoved basically the rear clip through the seat and pinned him against the steering wheel. That had cut the steering shaft off the car to get him out from that wreck.
That's a very good point that I didn't mention in the beginning. Is like if you're building front clips and you're building back clips, think about the failure, the way it's going to fail, and where those bars are going to go. I really don't like using chromoly in front ends in particular. We're a lot more prone to front end collisions. Because if the bar is cracking and comes loose at the joint, we have a crack we can't see because it's underneath powder coat. We all powder coat our chassis black because they're easy to repair if you can't see cracks. So if you powder coat them all white, you can see them. But when it breaks loose, where is it going to go? And that's another one of my nightmares. It's like getting stabbed with a bar through a race car. So yeah.
Yeah, I see where they, a lot of 4-link brackets today are bolt on, and nobody plates the front side of the bracket on the left rear in particular. That's one to me that should be a mandated plated area to keep, you break a 4-link rod from shoving through your back.
And I don't think the left policy even has a minimum wall thickness on the back firewall.
No, there's not.
Right. So
It's all 40,000. Yeah.
yeah, I mean, like my son's car is 40,000. Yeah, I mean, like I see that.
That's one thing, looking at cars that I've worked on personally, that's one area that I will pay attention to. Is like, we're gonna plate these 4-link bars here because you get that.
I got down that. It's something we need to do. The seat mount at the bottom of Turkey, I'm not picking on Turkey there. That's actually, I was giving him a high five on that because that allows you to attach the seat to the structure underneath it and gives you some adjustment in it. It's an aluminum bracket, but I was always told this may be wrong, but the seat just kind of positions you in the car and it doesn't hold you in. But at the same time, I don't want the seat moving around. I don't want the any structure stabbing me or whatever. This is just a question. Fire suppression, I've seen a lot of racetracks across the country. We're getting away from chassis for a minute. A lot of racetracks across the country that, utilize local fire departments and so forth to kind of help support the fire efforts at the track. Now, while that's great, they may not have the mobility in their operation to be able to respond quickly. They may be blocked in an infield. They may be positioned in the wrong spot. My question is, is there a way for racetracks, promoters, sanctioning bodies, et cetera, to look at purchasing something like a 100-pound or 125-pound fire extinguisher from Granger, like $2,000, strapping it on an ATV so they can be a first responder to an incident? You're talking $2,000 investment can save somebody's life. And they can use it all year, it doesn't go bad. I mean, as long as it reads green, it's good, right? And then the other question was some tracks used to do it, but nobody's enforcing it. Why don't we require every race trailer in the pit to have a 10 to 15-pound fire extinguisher in it? Why is that not, when you're rolling the game, why are insurance companies who insure these racetracks not pushing for that? It feels like they could give a discount on their premium if they made that amendment. So if nobody's thought about that, maybe something to think about. With my son racing, a lot of things go through my head as a parent, and fire is my third. There's no really order to these fears, but they're all pretty much equal. But fire is a huge one. And so as a dad, I thought about, okay, I'll just start building side by sides. Because they've got some cold suppression systems that are fairly small. It's called cold fire. I don't know if cold fire is doing it for somebody else, but they sell these rigs, these drop-in rigs, going side by side that they can have a cold agent that puts out gasoline fire. I was like, well, I'm just doing those, and that'll be a 50. So I can run around and respond if I need to respond. And I was actually trying to get some manufacturers, shops in the area that sell side-by-sides and ATVs to endorse that. So they could donate a side-by-side, if they were local to that racetrack, donate a side-by-side to the effort. The racetrack and some sponsors buy this drop-in rig, put it on the back of it, and now they just sticker this thing up, and now they've got rolling advertisement that they're #1 fan base, the biggest user.
Yeah, I know the other one that a lot of people don't think about is when you go test. You rent a racetrack and they go, they're not mandated if you have a fire department there or anything like that. I mean, yeah, the likelihood of something happens is pretty slim, but what if it does? So as simple as having people on either end of the racetrack with a fire extinguisher, even that you bring, is a good thing to have. I know we personally always had one on a four-wheeler when we tested. We didn't always keep it on there, at a racetrack while we were racing, but while we were testing, we always had one on. But that's something that is easily overlooked.
But one of the guys once told me, like a lot of these safety bodies, we're all going to fire suppression systems. I think that's great, fantastic. But I think we should have a fire extinguisher not that small. Why? Because that
fire system tested at the racetrack. Yeah,
Well, it's only a problem, this thing is only a problem when it's a problem.
Just like every other.
Right, it's only a problem when it's a problem, when everybody's talking about it, there's another issue. I get it 100%, but what I'm saying is like, Vice Mayor once said, the fire extinguishing cockpit is not for you, it's for your buddy. So when that dude's on fire, you pull over, you unstrap, you get out, you do what you gotta do, or hand it out to, a corner worker, throw it out the cockpit so they can help address the situation. I think that is something that it's a $30 deal, like, why is it not a mandate? And I got my opinion on a lot of people don't mandate things, but not for this conversation. So, my reflection on this entire thing was, why are we using materials prone to stress cracking in a safety region of the chassis? Why are we using subpar welding techniques on those materials? When do we acknowledge the fact that the industry as a whole seems to be prioritizing performance over safety? Right? And this is just an open-ended thing here. I mean, like at this point, I want to open up the question for anybody who's got anything for me specifically. We can wrap up or have a conversation afterwards. But I've tried to cover everything I could. I've been cramming on this presentation for a couple of days.
So as a chassis builder, and other chassis builders too. So as a chassis builder, other chassis builders, that may be in the room, as far as, being in this seat industry and seat mounting, where if you look at NASCAR, so we're next door to NASCAR and, we have a relationship with them, we're allowed to go over there and do all kinds of stuff. And they've mandated, so every chassis is exactly the same, right? Seat mounts are in the same place, brackets are, everything, all the chassis are the same. Now, I know you're not gonna get that across, the dark market or whatever. And I know sanctioning bodies aren't gonna do anything, because I've had long conversations with those guys and, it just comes down to liability, right? Then they'll tell you to do something and then you hurt when they use it. So, but as a chassis builder, and maybe there needs to be I don't know if you all meet or you all discuss things or you all do this or there's an association or something like that. But if we could get, certain things, homologated through the chassis process as far as seat mounts go, like NASCAR does and stuff like that, is they're the gold standard in the US for that stuff. That would allow, I know in our industry, seats to be mounted properly, which then falls down to belts, and they get mounted properly at the right angles, and all that stuff tends to work out a lot better.
So what you're saying is we need a centralized sanctioning body that has some rules that are a must for the dirt track racing.
I think chassis builders could take it upon themselves, right, to do certain safety things. Because the little statement you had there about prioritizing, performance over safety is innate since the beginning of
Racing, that's just racing.
Right. When they invented the wheel, the safety went away, right? So, yeah, and I don't think a sanctioning body's going to do it. Unlike NASCAR, who's really has an iron fist, right? These other sanctioning bodies can do it. And the other thing is like racetracks and why they allow stuff like that. It's just they don't have the personnel to police it. They don't have the personnel to police it, and then they're worried about the guy. Well, Joe blow down the street will let him through the gate. So if I don't get his $50, somebody else is going to get his.
My thing is that like how if that is true in its entirety, how does NHRA and these drag strips mandate gates inspections?
Any racing, Joe.
I get it, but I'm just saying, even if I go faster than 12.5, I have to have an inspected gauge. Right?
Well, the thing that you run into, like in our world, is, from a dirt lane hall standpoint, Worldwide Halls and Lucas both have done a good job of trying to get some of these safety things put in place between the seats, between the fuel cells, between the fireballs, and it has made great gains in that market. But the sport compacts of the world, the hobby stocks of the world, is the more guys that are doing more stuff in their own shop in the world, I think that's where something like this getting out to them, to give them that information, because I mean, there's really never been much information out there to be available to that world. Whereas like in NASCAR, it's, you know, heavily sanctioned, it's heavily inspected. You know, you go to one of those events and they'll have 150, 200 inspectors there. So they have the personnel to do that. You're never going to have that in this world. So I think having the information available, like what we're trying to do here, is good. In the sprint car world, the open wheel world, the mini sprint world, there has been some big pushes there trying to make that safer and better, you know, from a performance versus safety standpoint. In the U.S., for years, there's been talks of wanting to get the halo bars in, the Stevie Smith bar mandate, and things like that to help some of the things that's happened in the U.S. Well, whereas like in Australia, those have been mandated for years. That halo bar that goes over the top, where, you know, the wreck that took, what's his name? Paulson was one of them. Raging Cajun, what was his name? Jason Johnson, he was another one. That halo bar would have more than likely saved them. But no one would run it because it was a performance disadvantage and it wasn't mandated. But I think, you know, it's all coming down the line. There's a lot of cars, you know, you go to the shootout last week with 900 entries, over half of them had the halo bar in there.
At some point, people just, become self-aware.
Yeah.
Like, okay, I'm just gonna do this for me, regardless of what the impact, right?
Yeah, we'll figure out how to make it work.
Well, and I wasn't impressed, I mean, really the sprint car community is actually doing a pretty solid job of trying to get safe. I mean, because that doesn't work catastrophic, you know, like wrecks.
There's still some things there that we improve. Danny Dietrich's a prime example. I get on Danny's tail every time I see him. His head is out, is over the top of his cage.
Well, and I saw him doing, and this is several, you know, video, and I actually tried to reach out to the company who was doing the testing so that I could get some insight from them if they were still operational, how it was going, et cetera. But I saw him actually doing a drop test, you know, outfitting the cages, restraining cages, doing a drop test, and actually trying to correlate the stresses that the real world was, you know, how it matched up to the simulations for those particular ones.
You may know, what's the distance that your head moves in a rollover?
Per inches, probably.
I think that's dependent upon a lot of factors.
Yeah.
That's dependent upon seat, that's dependent upon seatbelt, that's dependent upon the body.
Yeah.
It'd be tough to say.
Well, I know Ryan Priest's head moved 9.5 inches.
Yeah, I mean, it moves a long ways, but yeah, Danny's head is usually even with the top of his cage, and he won't run on a taller cage. He's a tall guy. He won't run a taller cage because it's such a performance disadvantage.
Yeah, that's just a choice at that point.
It is.
I mean, it's a choice.
And we give him a hard time about it all the time.
Well, as racers, we make those choices. I mean, and you're the only ones that can make that choice. But all I'm saying is, you know, you can't get on the internet and bang on a keyboard and complain about the sanctioning body and still be making those type of choices. You know, like, so, I mean, you know, you can't save them all, but, you know, if we can save one or two. I'm sure. Right? Ben? I want to take that.
You got anything?
You good?
All good?
Thank you.
Appreciate it very much.
Y'all want to take a quick break, run the restroom, bombs or anything, real quick? Just do that.
Probably like that, celebration of Bible. During the roll. That's pretty fantastic.
Yeah, I mean, I never shared it to my first
But still, I don't think what we're not saying this is the best, we're saying this, we give you the minimum, but they won't. Just slap off. Hey, that was this one. What I'm trying to do, I've got another slide coming along this year. It might create some waves, but it's going to include access that are not. Instead of having to run every year, time is because I feel like my people don't do the documents because of the time it takes to research. So if I can get the system like make this big, like all of that, I had to scout it and tell you, look at what you're saying about it, try to figure out how to do that. But we use it to go to the other stuff. And then if I can take and incorporate trusted sources, prioritize that response to someone who always wanted to see. So you've got to go to the box with a trace card and see if you take out related to the board. In fact, let's not have them in here, those buttons. But say, hey, I want a button. See, how do I have the buttons? What's the best one? See the best like that. And getting actual response back from your website. Especially like for us, we got to do drivers.
Turn it off.
Soda bars.
Yeah.
Oh, hey, Ron. All right. Well, I'm early for 1 o'clock. I'm gonna find Richard.
That's how I welded in high school with an arc welder.
Yeah, we'll show that.
I think the heat zone was perfect on that one. Yeah.
You ready, you going?
Yeah.
Hello? Everybody ready? We're going to talk seats. We got victory seats, Chris Ferguson and Butlerville both. So we'll, I don't know. We'll let Butlerville maybe speak a while, and I think Chris wants to ask some stuff. So if you got some things you want to go over on some seats, that'd be great. Just have to talk in the microphone, that way it can be recorded. Okay. Well, that's one way that is recorded if you talk in the microphone. Oh, okay.
No,
Yeah, come up.
All right, how was everybody? Everybody out there? Cold, yeah, it is cold in here.
Yeah, we found the thermostat over here, we turned two snowflakes.
Okay, we got some heat, heat coming, I'll leave my jacket on for now. So a little history on myself, I drove a race car for, I don't know, 8, 10, 12 years. And notice I said drove a race car, not a race car driver. Those are two different things. So I kind of ended up being an owner. I owned a push team for 10 years. So that crash that he showed with the 44 car is, my car was actually
Let me see here.
all right, this one works. So yeah, so I got to see that happen, and it was probably one of the most unreal things I've ever seen in my whole life. And I know Mike personally, so he definitely survived that. But I just want to say, like in our world, I guess the biggest, we go through, we get again next door to NASCAR, and then we're building a NASCAR seat, so we have a lot of high speed camera feedback from them, and looking at what happens in a crash. And so I get to see that Ryan pre-stress, how much the head stretches and the belt stretch and stuff like that. So the biggest thing we see, injury-wise, is obviously head injury. So I don't have a lot of graphs and stuff like that, but we do a lot of drop testing over at NASCAR with build-ups that we have. And we change build-ups. We change foam, closed cell foam, open cell foam, things like that. We mix and match, and then we send it over there, and they drop test it for us. So I think the biggest thing on a high speed, so we've been looking at is your clearance, right? So we have a high speed test, you have a low speed test, 7 miles an hour, 13 miles an hour for your head movement. So in the graph, I don't have any graphs with it, but the biggest thing in the graph between a 7 and a 13 mile an hour, which you wouldn't think is huge, is actually phenomenal, the amount of difference. And our engineer here can probably vouch for that. So the biggest thing to do, what we found to do, as well as absorbing that, right? Because we have 45-2 foam, is you limit the distance the head travels. And the big thing right now with NASCAR is rear impact. So the car gets backwards, driver naturally does this when he's going to back in, that increases the distance and increases the force in which the helmet contacts the pad. So everything that we're doing right now is 45-2. We went to, this is our kind of standard sprint head right now, 4 inches of SFI, and then we play with this. We stick with the 4 inches of SFI right now because I tested best, and then the helmet's probably 10 3/4, so we try to make it 10 7/8, 11 at the most, and then we mess with these comfort foam, we call it, or decel foam, to try to limit, to slow it down before it hits that. And to get back to some of the other things, as far as seat mounts goes, and I was just discussing that with him. I guess seat mounting is the biggest maybe issue that everybody has. So we had a Bandolero seat come back that was pretty twisted up, and
was pretty alarming to me, so I kind of looked at that and I asked Dad, hey, do you have a video of the crash? Do you have this, that? I said, well, I have an aim car. So I forget what racetrack they're at, so I think it was a 3/8 mile. And they have bandoleros at a 3/8 mile track. And these kids are totally man. I mean, you can see the kid's in the corner, he's doing this, he's loose, he looks like a dirt guy. And the next thing you know, he just overcorrects a little, turns left again, the thing hooks, and I mean, he absolutely turned the wall. So I'm thinking to myself, gosh, boy, he hit hard. But then I'm looking at the seat mounts and where he had the seat mounted to where it twisted. And I think a lot of the movement in the seat was due to the actual seat mount. So I think that's something that when you're mounting, everybody out there in podcast land or stream land, you need to mount the seat right. So we have directions, on how to mount seats. You can call us, whoever your seat manufacturer is, call them, ask them about how to mount your seat, and that'll save you a lot of headache. The picture with the guy with his glove out there, he obviously was an info containing seat, and he probably had that thing mounted absolutely ridiculous. So, the other thing we do is a lot of, SFI testing with impact, pushing, doing stuff, as far as, the integrity of the seat itself and how much it gives. And then we did a little bit of testing here recently on, how your body reacts to that, to, the seat movement itself. And the data is really showing now that, and NASCAR is doing a study right now on spine, but a little bit of movement in your seat, is a good thing. So you got that bone, you're impacting that, and then maybe just a little bit of movement too in the seat brings everything to a gradual stop. And that's what we're really trying to achieve. So we did a test probably 3 months ago, and we changed 4 different things at 4 different tests, which, each test, costs money, but we figure it's worth the investment. So we actually had a person in California where the testing is, and we sent him, and then we started at one point, and we just added a little bit at a time, so we reached that, kind of sweet spot to where the seat gives enough, but not too much. And so I just want to know, that's a lot of technology stuff that, is really boring and graphs and all that stuff, but you don't really realize it until you crash, right? And that's when you really want it. So as far as that's concerned, and I think the foam is the biggest thing, and that's really what I'm looking at, and that we're spending a lot of time on. There's some new foam out there that's at high speed and at temperature, which of course you've got to drop at different temperatures too, right? So 122 degrees is the max, which you'll see like even this comfort foam right here, right now it's pretty stiff because it's cold. You put that at 122 degrees and it turns into gel, right? So not quite gel, but so we have a new foam out there. There's a couple different manufacturers out there that are making new types of foam and testing them. So there's new foam out there that tests right about 43% better than the SFI 45-2 at 3 inches. So we've been using that foam. It's an option on all our stuff. Again, safety, performance, where you're going to spend your dollars. That's probably the biggest problem that we had since the invention of racing. So we encourage you to spend a little more money and maybe get a little better head foam and stuff like that. So, and then getting to so we're in the dirt market, and I guess this is a dirt market thing. But getting to like those 4-cylinder cars and stuff like that, I guess that they've mandated now, most tracks have mandated, full containment for those guys. Yeah, I think so. I've had some, I've had a lot of feedback on that. So, some of them, no.
Depends on where you go, if you go to Arkansas or not.
Yeah, I just know in this, I know like South Carolina and stuff, and, this area right here, we've gotten a lot of inquiries because they said that they mandated, full containment for those. So, and I just say that, to say that, okay, those guys aren't gonna spend $2,000-3,000 for a seat, although they should, they're not gonna do it. So what do you do with, okay, that seat right there, I think on the left is, I won't say the brand, but, you know, is probably not the safest thing in the world, right? So now you can put Head and Shoulders on that, you know, makes it a little bit better. But for those guys in that market, you know, we really need to try to make something that's a little more cost effective. That's going to be, you know, a heck of a lot better than that right there. So I don't really know what the answer is to that. At the moment, we do make a, you know, a more cost effective seat. I don't really like it. You know, we would sooner somebody, you know, step up and buy a better seat. But, you know, obviously being in the market, you know, we have to realize that there's a demand for that too, and that void needs to be filled. Because not everybody, again, can spend $2,000-3,000 for a seat. So, and then I won't get too much into belt placement, but we do have, working on some things for, belt placement, maybe doing some all belt stuff like we do. You know, we use NASCAR as a gold standard because they're out there, they're doing testing, they're doing this, they're doing that, we're talking to them and stuff like that. We see data from high-speed crashes. So we're trying to incorporate that into the sprint car market, into the dirt late model market. Man, right down, you know, to the 4-cylinder guys. So it's something that can make those seats a lot safer and make your belt placement right so that you can't make a mistake. So we have to label the seat, you know, LB, which is lap belt, right? NASCAR makes us label that. So we can take that technology, move that into the lower market for very low cost. So we're doing, working on that, and we encourage people to, you know, definitely look at their belt placement. Now, I noticed his graph said 20 degrees, but NASCAR, kind of, again, gold standard, they allow 3 degrees off of that. So it's 93.87 in their stuff. So any questions about like actual, I guess, seat integrity or anything like that? I know you're looking, so.
I got a question.
Sure.
It's about the seat mounts that I've seen in my case. I mean, not the sprint guys even. Sorry. That one working now?
I think that one's working
I've seen these seat mounts that the micro sprint guys use. Where are my green marks? Somebody lost it.
now. That's right, use a blue one.
It don't work. I had it. That's what I do with it. But he's walking down where. I don't know where. I don't know where's that? There, where's there? All right. So these micro, I mean, these sprint car seat mats, what they're doing is they've got your roll bar through here, and then they've got a collar that went around it, and it has some sort of triangulations in it, right? And it's like a rubber insert, and then the mount actually went off of that. My understanding of the way that mount works is that handles high frequency, low amplitude, right, things. But the thing is, you're introducing an area for motion, which, so the compression curve on that looks like this. So you get a huge spike in spinal load, and most of in my understanding is most of the injuries, the spinal injuries, are due to compression and rapid compression. So I would encourage anybody who's looking at this style of mount to maybe look into the science a little more and see if you can figure it out. I'm not trying to knock this company down or anything, but I think that's introducing a problem. It might aid in comfort just cruising around the racetrack, but in the event of a hard hit, that could be a problem.
Yeah, no, that's right. I mean, he's right. So now they have the new new chasm system that's out there, which is, you know, not quite like that, but, where, you know, compression is a great concern, right? Especially in the sprint car, you know, when you're coming down, you have the four-wheel drop, bang. You know, all four wheels, suspension's gone because it flew off, you know, 3 rolls before that. In a car that bottoms out. So we've definitely seen, you know, some spinal injuries for that. So it's a huge concern, and, you know, I think that, you know, some of the things that are out there right now, like the chasm system, definitely helps that. You know, it's got, I don't know if you're familiar with that, but it has, you know, it's got pucks on the bottom that are different compression for different weights, so they compress at different rates. So the 300-pound guy versus a 65-pound guy, right? So you can adjust those pucks. And then the back's on a slide system. So you have this, and you have your little slide system like that, and then it's got a pin here. And then when the pucks collapse, the seat in the back drops, right? And then that's put on, that's connected to this board. So the only problem I see with that, which David Gravel, we do a lot of stuff with David Gravel, so he's like our test guy, does a lot of R&D stuff for us when we come up with new ideas, he tries it. So last night I was talking to him, probably 45 minutes, and I had a caliber in my hand, and he was installing that, which he used the weld-on tabs, and I have the bolt-on tabs. So the problem with that is that you have an aluminum piece with an aluminum thread that you're then bolting your seat to. So that's obviously a concern, right? So I know on a conversation that I was about that they're using your shoulder harness, you know, in the test for us in order for the resistance for that seat to come loose and to pull out. So if you didn't have, if something happened, so your belts, you had cam locks and your belts came off, right? And then you end up with no belts, you crash, now you're in double trouble because the back of the seat rips out of, you know, the aluminum thing. So you're putting a grade 8 bolt into an aluminum thread. I think it's 5/16, so that's not going to hold a whole lot. So that's a concern, and I'm kind of looking at trying to figure out, okay, we need to figure out how to through bolt, right, and still allow it to slide up and down. So I think that's a good way of doing that, and then trying to say, okay, so then you're dropping, and then that's allowing your seatbelts slack in your seatbelt. So now that creates a problem because that dominoes to your head and neck restraint.
Hey, Fred, do you know how much that chasm moves? Is it 1 inch or is it a 1/2 inch?
Looking at the throw, I think it's like right around 1/2 to 3/4, maybe 5/8.
So I think me and Fred probably both agree on this, and people sometimes miss the point. You know, it's 3/4 that they're trying to eliminate drop or, you know, slow it down or whatever. You could easily put 3/4 inch of SFI foam under the butt of your seat and do the exact same thing. Or not the exact same thing, but help compress with the spine. And a lot of people just choose not to do it.
Yeah, so I that's a rule in Australia, right? You have to sit on 1 inch SFI. So again, we have some engineers that we work with, and they say 1.5 inches. So when we're building, especially in the sprint market, if they're not doing, you know, if we build a seat for an insert, that's a new thing that we're doing. We're working with Impact on that. So we're pouring an insert for them, taking that, scanning it, and then CNC cutting that out of 45 too. And basically what we're doing is, so we're going to build the seat, you know, a little bigger, right, a little taller, and then we're going to stick 1.5 inches under them, and then, you know, get them at the 1.5 inch level, then pour everything else around them, and then get that 45-2 lightweight insert cut, and then finished and put in the seat. So, but given that, okay, yeah, and then you put the pucks with it, right? So now you got the best of 2 worlds. But everybody in a sprint car market, if you're out there and you're driving a sprint car, I don't care if it's a 360, I don't care if it's a micro or whatever, you should be having an SFI butt pad in your seat, period. stick it under your cover, do whatever you can. It's definitely gonna help. Every little bit helps. So we see a lot of the, you know, a lot of those back injuries that, you know, they're just sitting on the seat. And, you know, we're building seats, you know, in case a drive shaft comes up and hits it and stuff like that, so they're pretty stout on the bottom. I mean, they have to be, right? Or the drive shaft would be, you know, you'd be childless. No, we don't want that.
Just when I've got a camera, but is that rule for that foam seat, the Speedway Committee rule? Australian Speedway Committee, did they set that rule? Who set the rule for Australia?
Yeah, so I just know that I ship a ton of them to Australia because it's a rule. So I deal with one of our dealers out there, and so I don't really know the name of the organization that the rule is under.
My understanding, like all sanctioned racing in Australia is one Speedway.
It is one Speedway deal.
Right.
Yeah.
Across the board.
Yeah, so then that would be a mandate for them. Yeah, absolutely.
It's actually their insurance company. Like, they only have one insurance company for all the racetracks over there. And you, like, when you go over there, you don't go up and buy a pit pass. You have to buy a pit pass as a member, or you buy a pit pass as a guest. But basically, your guest pit pass will be more than a member pit pass because you're paying the insurance fee separate. So, like a normal pit pass over there, like when I went over, was $100 because you had to pay the extra insurance fee. But that's who's mandating all of these safety rules for all the classes over there. It's not just one particular class. They go from start to finish across the board. So they, which, you know, granted, there's way less racing, way less racers over there to try to police and mandate all that stuff, but they get it done.
Yeah, I think the biggest problem that we have here, you know, is you have so many levels of who's looking at the car, who's inspecting the seat. You know, every series is trying to keep down the cost. You know, I know we did some stuff with Dale Jr. and was saying, okay, well, you should really mandate this 39.2. You know, you guys are going fast, you're doing this, you're doing that. And it's like, oh, the first thing they thought is when we bought the series that, you know, we were going to raise the cost. And, you know, literally the first thing out of his mouth. So I get it, and I get the fact that you have to make it affordable for people, you know, at every level. But on the flip side, somebody needs to be looking at this stuff. You know, we did a lot of work in the junior dragster market. I know we're in the dirt series, but so his parents like, well, we ain't going to crash. Like, really? Like, sooner or later, somebody's crashing, right? It's not a question of if, it's a question of when. So we ended up, you know, meeting with NHRA, doing this, and getting, you know, 45.2, 45.1 robot pad, and 45.2 foam head pads in the juniors, and as well as a head and neck restraint. So, you know, especially, you know, if you go back to, you know, the cards, micro springs, quarter midgets, they're the worst. They hang out of the car. You know, I just don't understand it. But you can only do so much, right? So we're just trying to do our part and limit what happens when you're in our seat, and limit the amount of stress that your body takes. You know, you don't really see a lot of broken legs and this and that, right? So the only thing you really see is, you know, head and back injuries. And, you know, the Hans and hybrid and all that stuff has really helped with the neck stuff. And I just think it's the next evolution is to really to get everything integrated. So, any other questions?
You say something about carrying a $5 helmet and a $3,000 seat. How that doesn't really make sense.
Yeah. Well, I mean, everybody makes choices, right? So again, I spend a lot of time in the junior dragster market just because, you know, we have a line of product for that, and you know, you get a 3-inch cushion in the seat, and then you're strapping belts, and you're like, okay, well, what happens when you crash and you can press on that, right? So that goes for your guys in their pure stocks, and you guys in your, you know, you get your buddy's seat, and he's 200 pounds and you're 150 pounds. and then you throw a pillow in there and some couch cushions. And that's gonna help you. So you're gonna compress, your seatbelts are gonna get loose, then you go the opposite direction and it rebounds you, and then you pull against everything, which the rebound's a whole nother issue. So when you're testing, it's about rebound too, right? So you do a drop test, you wanna absorb that, and then you want that rebound to be nice. You don't want it to spring back, so that's where you get sometimes into trouble with some of these foam. I know there's another manufacturer, it's not a seat manufacturer, but a manufacturer out there of head foam and inserts. And I mean, we've just seen so many of them, and you know, I obviously take your competition stuff and took it down and drop tested that, and it was literally horrendous. The graph just went just straight drop down like that, and it right back up. And I'm like, so you're doing really more harm than good. You're better off with just the aluminum there at that point. So you know, you just gotta pay attention to that stuff. You can't be putting cushions in your seat. That's the biggest thing. You know, we obviously build custom seats, right? A 7-point measurement. We build it to fit you. If you want to insert, you know, we build it a little bigger. We do the insert. We can do a scan CNC insert, totally 45 tubes, 3 times less weight. So the average insert for a sprint car is around 1,150 grams, and ours completed CNC about 420. So you just want to definitely do everything you can to mitigate the movement of your body, and you know, to cushion and bring everything to a gradual stop. Everybody knows that, right? You go to the stop sign and put on the brake, you know, and you glide down nice. If you're a woman, you wait till you get to the last. No, I'm just kidding. And you slam on the brake, and your coffee runs and hits to that, right? Same thing. Same thing. It's really not rocket science. It's just about that. Any other questions? We're good. Yeah, if you need directions or whatever, of how to mount seats, whatever, some data and stuff, we're gonna have all that stuff available. Just go to our website and check it out.
Thank you. Thanks. Chris, you got some things to add here?
Hey guys. Chris Ferguson with Victory Seats. Trying to simplify it a little bit. Fred did a great job of showing everybody kind of everything that we're all kind of working towards. Everybody has the same goal of saving race car drivers if you're in the safety industry. So a couple things right off the bat. There's a lot of short track races that's going to be here this weekend. There's a lot of drivers that are probably here that's bought a used seat, bought a seat from somebody else, especially when you first get into the sport. The first thing you want to do is make sure that that seat is actually built for the right application. I see this all the time at Charlotte, at the dirt track, at asphalt races. There's a guy running a sprint car seat in a dirt late model, and it's just wrong. Fundamentally, the seat's built not correct. You'll see a sprint car seat in a front-wheel drive car. It's just they see it on Marketplace for $400 and bought it, and not knowing, they don't realize that you could easily get yourself hurt doing that. So a couple of things, like I'll just kind of explain it on a seat. So long story short, this is a 20-degree seat, pretty common in all of dirt late model racing and all of short track racing. Asphalt's a little more laid back, but then sprint cars are more, upright. Well, long story short, a 10-degree seat, you take the back angle, you come up, 10 degrees. Naturally, your spine's going to compress a lot more when you have any kind of rough track. We've all raced at, I ain't going to name tracks right this second, but rough tracks, and when that spine is sitting straight up and down compared to laid back, you're just it's more than likely that you're actually going to have a back injury. So that's why every other form of racing besides sprint car racing lays the seat back, kicks the legs up. And also what happens is people try to, like if
you do have a sprint car seat, and you bought one by accident, and you're like, man, I can't get comfortable in the car. First thing drivers do, they take the seat, they try to lean it back. They try to make it 20 degrees. Well, this seat is fundamentally wrong. What happens is when you lean the seat back, get it back to where you want, the legs kick up a mile in the air. So then your legs are actually hanging. You can't reach the pedals. Performance-wise, you're never going to drive or win races doing this. So, but people just don't know. So really what happens is, whether it's, a sprint car seat or an asphalt lay model seat, seats laid way back. What's happening is if you're sitting in a 25 degree, 28 degree seat in any kind of short track car, your arms are extended, and anyone that's trying to drive and run the cushion is never going to be able to control a race car with their arms completely out. So that's kind of the first thing I wanted to say, because I see it all the time. It's just not. Make sure that when you buy a seat, whether it's a Victory seat, Butler, LaJoy, Kirky, if you don't know what it is, call the manufacturer, because they can tell you what it was built for. And truthfully, they'll tell you to steer away from it if it's bad. Like I said, we're all kind of in this together. There's just so many things that can go wrong, and there's information out there. I understand it's not at the track. I understand that there's not a lot of people that are walking around the pits, but everyone's got internet on their phone now. You can go to all of our websites and find the phone number to call someone, so it's not very hard to really reach out and find out. And also, like the other thing about, like I was saying, if you put the wrong seat in the car, like you were stating earlier, that the Halo, 10 degree seat, the headrest is going to be 2 to 3 inches higher. So then you're sitting up higher. There's so many things that really come into play. So that's the first thing that really I wanted to touch on. There's just a lot of things that can go wrong. So I'm kind of here to kind of show you guys what to look for that's wrong, and also what to look for as far as just every little aspect of the seat. I know Matt didn't realize this was going to be driver participation, but I'm actually going to have him come sit in this real quick to show you guys some things. So, this is Matt Henderson. He's won a bunch of races.
Way to go, man.
Yeah. So clearly this seat was not built for Matt. You can probably fit 2 of them in there. So a couple of things that you see right off the bat. Let's just say Matt saw this seat. He's not this guy, but he saw it on Marketplace. It was $500. He's like, oh, this seat's great. I can make it work. You know what I mean? I can put an insert in it and make it work. Well, there's a few things fundamentally different about every race car driver in every seat. So the first thing that's like leaping out is how far the rib supports stick out. So the guy that I built this for is Sam Seawright. Sam's what, 215, 220? How much you weigh? Yeah, he weighs 165. So there's 65 pounds difference there. This seat's not going to work for Matt. Even if we pour an insert, fill in the sides, it's fundamentally wrong. So if Matt looks straight ahead, his sight line's okay, but his seatbelt holes, his shoulders are about an inch too high. So that gap is different from every driver, from his sight line to his shoulder belt to up under his ribs. Everybody is different. Every human being is built different. There's none that are exactly the same. So you can do your best to try to make a seat work, but realistically, you're setting yourself up for failure, number one. But the most important thing, you're setting yourself up to get hurt. The second thing that's really bad is, this is where I get a lot of phone calls about people asking, both of us want to drive the car, like a father and son. Can you build a seat that'll work for both of us? Well, the back measurement that we all take is a width that sits in between their arms. So the first thing that you measure is, you measure across the back and then you build the rib width that width. Well, let's just say the father's 15, 16 inches, the son's 12 inches. Well, these rib supports are always going to be out, and they're going to always hold out on his arms while they're racing, even if you fill the inside up with 2-3 inches of foam. So this is stuff that people think is a great idea, but then they don't realize they're just setting themselves up for failure. regardless. The seat is also built too high around the leg area, which, as you can imagine, getting in and out of the car is super important to us. So if we can drop this stuff, lower this back, his chest step, you know, I'm not saying Matt's a bird chest or anything, but Sam's clearly 4 inches thicker than he is. And all this is intrusive. When he holds the steering wheel and he tries to turn to the left, everything's going to hit. So just because you see a seat on Marketplace, don't go buy it. At least go sit in it and have a professional look at it. And there's just really a lot of things when it comes to this whole thing. The sight line to the headrest is super important. Like Fred was saying, the headrest foam is massive, but also the head placement. You know, if this headrest was, I don't know, 2 inches higher or 1 inch higher, you know, the bottom of this head is going to come out the bottom of the headrest. If this headrest was 3 inches lower, catastrophically, his head could come out of the top of the headrest. So you want to make sure that your sight line, your cheekbone is directly in line with the foam on the headrest. It's super important as far as impact, as far as racing wise. You know, you got to be able to see if someone's on your outside, because the way you probably turn this self head on into the wall if I was on the outside of them. And a lot of people just don't know to look at this. The other thing that's important, foam, like he said earlier, you know, it does change as far as temperature, or most racers do. People that probably, if they don't watch race cars, they probably don't need to be at the racetrack. But what happens is simple green, everything else, the water, the fabric, everything that open cell foam on this head foam. So typically speaking, after about a year or two, you know, you feel this foam, it was once comfort, and now it's hardened up. The good thing nowadays, you can send this back and replace it. All of us manufacturers do. Like it's super important. Like we can build a great seat that's structurally sound, that does the right thing. But if the head foam feels like a brick, you're going to get a concussion every time. So, and we try to limit also the travel in the head. Like Fred was saying, you know, we close this gap up, and yes, there's people that are, especially some of my old school friends that's kind of older, they like to claim they look at the spooler. And I listen, I've raced with some of the best of them, and I promise you, I've never seen anyone turn around and look backwards at their spooler. But I do understand that, you know, you do want to open it up, you know, because there is a little bit of preference there. So we try to eliminate as much as possible, because when you eliminate that gap, you don't have no whiplash. You know, you're already up against the foam when you crash. When you do have that gap, you create more speed, you know, more contact, and ultimately resulting in probably more head injuries. So we try to slow all that down with this.
Is there mounting wise, is it preferred to be straight left to right, or is there, I mean, like O'Neill, for instance, he lays his darn near 20 degrees to the left, it seems like. Is that something to take into consideration while building the seat?
Well, it's not particularly, because, you know, when you rock a seat up, the driver's going to move up at the same direction. But you do want to make sure your seat belts are mounted in there correctly. So if you have to space up the right side, or you know, put one tab higher than the other, you definitely want to do that. As far as mounting goes, like I tell everybody, anytime you can spread the load in any kind of application, whether it's building chassis, building, you know, anything, it's when you can spread the load, it's better. So I see, when I go to the racetrack, I walk up and people have 2 bolts in the back of the seat. The back of the seat is 12 inches wide, 15 inches wide. And there's 2 bolts that are 4 inches apart. That's not spreading the load. That's literally setting yourself up for failure. You know, that pivot point is so close together that any kind of crash is going to manipulate the seat and push it. Whereas if you actually, like I always tell everybody this, I put 4 bolts in my seat. NASCAR mandates that. In the shoulder area, it's got to be 4 bolts. And it's because it makes people spread the bolts out. It makes people actually spread the load. On the push test, it actually pushes about double what 2 bolts do. So, I mean, that's common math, right? 2 times 2 is 4. So, I mean, it's double the amount of strength that you can take when you put 4 bolts in there instead of 2. As far as the bottom goes, you know, the rails are nice. It's definitely not applicable on dirt models nowadays, but short, you know, lower division cars it is. But I always tell everybody that the wider you can get, minimal 3/8 bolts and everything, you know, but that's if you have 4. You know, if you want to, I don't really suggest putting 2 in there ever. I think that 4 is a lot better. But Fender, you know, bigger washers, grade 8, you know, not just a body washer. There's been hard enough impacts that we've seen the bolts tear through them. And the other thing too is when you do buy a seat or you get a seat and it looks like Swiss cheese, take your seat to someone that actually will weld up the holes or weld up, put a plate there and fix it correctly. There's aluminum fabrication places everywhere that can fix that. Just because, you know, you got to throw it in and go race, it doesn't mean you can't spend an hour taking it somewhere and getting them to weld the holes up. So we've seen the seats bust out plenty of times too. Really, when it comes to mounting, every car is a little bit different, so it's very hard for us to really present a great bracket. I've looked at every type of dirt late model chassis and dirt model modified, and there's really not a, that's why it kind of is up to the end user and also up to the manufacturer to provide some, you know, type of guidance, which we tell them what we suggest, but the bracketry in between the seat and the actual chassis is so different on every car. I've seen them 90 degrees. I've seen them, you know, vertical, horizontal. I've seen rails, like in Barry Wright's cars have had rails, the rail system. Blueco's cars have just a flat plate welded in between the roll bars that you bolt straight to the plate. I've seen tabs built. One thing that's very, very alarming, and I know you've probably seen this a lot, there's a lot of chassis manufacturers that aren't putting sub belts for the center substrate. There's not a tab there no more. So it's definitely that's a massive problem that people, and I understand that not everybody's in the same location front to back, but at the same time, you can get a general area. I mean, you're building these seats for people that are average 100 and let's just say the low side 35, 40 to 240. Let's just say everyone's within, because of where the cockpit falls, where the steering wheel shaft falls on, and you can only really get in one way or out. So you got a 4-inch window that you could put a tab there, and I don't see it on a lot of cars anymore. There's a couple of things that we've done to actually kind of combat that. We plated the bottom of the seats where they actually mount the seat belt. Very kind of similar, I mean, not similar to all belt, but you know, it's an 090 seat or an 1/8-inch seat, either or. But a seat belt could easily tear through that. If you guys actually seen the forces of the body when there's an actual wreck anywhere around 100 miles an hour, it moves a lot. So, you know, we were able to kind of plate the bottom of the seat to help that, just in case there's not a tab down there and people don't have the capability to put one on there, which to me, like I said, everyone should be able to do that. I guess pretty much a few other things. Really, like, when it comes to all this, you know, it's kind of our job to get the information out there. Everybody's kind of on social media, Facebook now, and don't believe everything you see on Facebook. You know, don't actually believe half the stuff, really. I hate to say it, but you know, talk to the professionals. Like, that's the first thing that I always encourage everybody. There's a reason why we build seats a certain way. There's a reason why we run certain helmets. You know, we run Bell, we run K1, we hooker harness belts are here. We have personal relationships with all these people. So, and even when you're not looking out for yourself, the manufacturers are looking out for you. And I know earlier we were talking about you know, the kids and family, well, you know, a lot of drivers don't care. Like, I'm an adult, you're an adult. You know, we're not as worried about safety, but think about if your kid was out there or one of your family members. And then at that point, it changes your perspective. So myself, I've got cousins that race. I got my wife's father, and my dad used to race. So we all have skin in the game. So at the end of the day, we're the ones that are really taking the next step as far as pushing safety and testing and really seeing what we need to improve. So like I said, if you have any questions, don't be afraid to reach out to me or any of the manufacturers. If you guys have any questions, I'll open up the floor, but that's pretty much all I have for now.
Good. I do have a yeah. I do like this year coverage, right? And everybody else is like. Real quick, I need to hit the end, but one of the biggest things with your style seat and others and everybody else's is price point, right? I know this isn't a sales pitch, but you got a lot of youth racers in the country and they're getting into the sport. I mean, do you guys do you offer any kind of trade-in upgrade program or anything, or are we looking at $3,000 and $4,000 investments every couple months with my kids growing like a week?
Well, here's kind of me and Scott and Neil just had this conversation. I always tell everybody this, you know, perspective. How much are you going to spend on a race car? On the low end, let's just say $2,000 or $3,000, like for a front-wheel drive car. You know, exactly. I mean, you're paying $2,000 for a Bell lightweight carbon helmet. Perspective. A kid's going to grow out of a seat, and you can build a little bit of growth in it. 100%. There's a little bit in there. We can put a little foam under it. We can do some things that allow it to be able to grow in, but the reality of it is you can't get 2 or 3 years out of a kid's seat. It's not going to happen. But hindsight, let's just say on the high end, $1,800, $2,000. On the low end, $800 to $1,000. You're spending that once every year and a half. How much is tires for that thing? How much is fuel? So as a parent, it's up to you to make that decision for your kid's behalf. And also, I see this more than ever now, especially, you know, at the go-kart track at Millbridge. There's parents that get into the sport that don't have a clue about racing at all because they saw it on TV. They saw Kyle Busch at Millbridge. So I go there and I see kids that don't know how to put their helmet on. They don't know how to strap their seatbelts, you know, and the parents don't either, which is scary. So I always tell everybody this because relationships in this sport, you know, I know the majority of people in this room. The racing family's pretty open to everybody. So don't be afraid to ask. You know, ask. If you don't know, ask. You know, when you're at the racetrack, hey, I don't know how to put my kid in this seat correctly. Can you look at it? You know, we can do, there's only a certain amount of us, so we can't get to there's thousands of racers compared to, you know, hundreds of manufacturers. So at the end of the day, it is your responsibility as an adult and as a parent to make sure that you're getting all the information and making the right decisions. But as far as a youth program, I think pretty much everyone kind of has one in some shape or form. I don't think you're going to have to spend $2,000 or $3,000. I think you can build a kid's seat under that for sure. But like I said, hindsight, you're buying this every year and a half, 2 years.
You made my point.
Okay, just making sure. Anything else?
Also add to that, you know, so I grew up in, sorry about that.
So I grew up playing ice hockey. Obviously, I'm not from around here, but I grew up playing ice hockey, and you know, geez, my mother used to complain because I needed a new pair of skates every 6-8 months, right? So it's kind of the, you know, to get his point, it's kind of the same thing. But then on the flip side, I have 3 kids who are racing, and you know that was pretty painful too. So I know that we have a program where it's one-time charge and you get 3 seats in 60 months to use it. So, and that kind of, and especially if you have more than one child, then you can pass the other seat down to the next kid coming, you know, as long as they're in the same growth pattern. And then you can kind of, you know, budget it out a little bit better that way. It makes it a little bit more affordable so that your child is, you know, at least safe. Because that's the biggest thing, right? When kids are racing, you know, they're pretty flexible, so you get a little bit of break there because they're, you know, they're flexible. They can do all kinds of stuff that us adults can't. But yeah, and to his point, you know, parents are the new parents. They just don't have a clue. More so on the drag race side, but even at the go-kart side and stuff like that, it's incredible the amount of industry ignorance, I guess, if you didn't grow up racing.
Anything else? Everybody good? Thank you, guys. Appreciate it.
I got Brad on Zoom right here. Brad Smith.
Oh, bad Brad.
Brad, he got the flu in Tulsa, but he's going to zoom in on me. He's supposed to be here. So it's going to take me just a minute. We're going to get Brad on. We're kind of jumping around just a little bit, but I want to do this because Brad's waiting on me. Just a second, Brad. Let me get lined up here.
I just need somebody.
Oklahoma side of the other reached out. And planned to be Well, obviously, and what causes fire in race cars? And we've actually studied sweat science. So we actually keep drivers up to 70% drier to actually help remove the moisture from the skin so we're not like the sizzle. Just for fun, take one piece of bacon, put it in your freezer, and you get the sizzle. Take the same piece of bacon the next morning and lay it out on the table and heat off your hot table your sizzle. That'll kind of give you an idea of what evaporation and moisture and sweat are doing. So we definitely try to stay away from that and keep the driver as dry as we can, but that's ultimately what fire protection is really about. Okay, SFI certified. I hear this all the time. You see the labels on the arms, on the neck, or whatever. SFI is an organization that was set up originally as a not-for-profit 501c from California, and they were basically a group of racers that were interested in making safety better. What is it applicable to for driving suits? So all driving apparel and accessories fall under the 3.2 and 3.3 applications. Let me throw this disclaimer in there. Please verify all the information I'm giving you with the SFI Foundation website. It is free. It is your resource, and if you're not looking at it, you're crazy. This could be your life. But 3.2 accessories and 3.4 accessories are driving suits. 3.2 is probably all you're ever going to see in short track racing. 3.4 certifications are only for NASCAR. So you see 3.2/1, 3.2/3, 3.2/5, etc. That does not mean the layer of suit. A -5 is not 5 layers. A -3 is not 3 layers. A -1 is not 1 layer. That is the amount of time that is rated for it to not create a second degree burn. It's basically done on a TPP rating or thermal penetration. So you can actually have a 1 layer suit that meets an SFI 30, which is the highest rated suit you can possibly have. This is going to be more powerful than an SFI 20 that a top suit dragster guy will wear. Unfortunately, that suit doesn't exist. It's kind of a pipe rating. Most of what we're going to be dealing with is 3.2/5 suits. Those are traditionally going to be 2 and 3 layer suits that we're going to see in short track racing, whether it be dirt, whether it be asphalt, kind of whatever track you're at. Just because a suit has an SFI label on it doesn't mean it's SFI certified. It would be like you putting a Goodyear sticker on a Hoosier. It didn't make it any more a Goodyear than the sticker did. There are counterfeit labels. In recent history, Impact Race Gear is the most current company to be decertified for using counterfeit labels. That's right. Bill Simmons' bread and butter company got caught using fake labels. They were importing labels using nylon thread, et cetera, et cetera. You can read all of that on the SFI website. For God's sake, don't take my word for it, but it has happened, and it has happened multiple times. Before you buy a suit, go to the SFI Foundation website. Look and make sure that that manufacturer participates for whatever item you want to buy. There's a separate certification for suits. There's a separate certification for gloves. There's a separate certification for helmet and underwear. If your company is not certified for all of those things, don't buy it. I don't care if it's free. I don't care if your buddy sells it. I don't care if your daddy sells it. They don't know what they're selling you. If they're just chasing your bucks and they don't have that $800 to become SFI certified, don't you dare trust your life with it. SFI is a great organization, and they really do a great job of policing what's going on in the industry. Brian, what do we got next? No problem, sir. Oh, clean and care. So
we talk about cleaning often with fire suits. One of the things that doesn't happen as often as it should. What we tell people about cleaning the fire suit is, unfortunately, grease and oil and gunk. And if your suit starts to get dirty in certain areas, those are actually oil buildups, which actually become flammable actually. So what we tell people is, you definitely want to make sure that the suit stays clean, but it's also easy to overwash it. Yes, you can actually over-clean the suit. It won't wash the fire protectancy out of it unless it's a fire-treated cotton product. But what it will do is it'll wear the actual fabric thin, and the thinner it gets, unfortunately, the safer it is not. It begins to lose its fire protectability. So what we recommend guys do, if your suit just smells bad and it's really not dirty, we recommend that you put it in your bathroom at home, somewhere that's climate controlled, heated and air, hang it up in your bathroom overnight, inside out. Once the suit is completely dry, fold it up and put it in the freezer. If you leave it in the freezer for 24 hours, the suit will actually smell fine. Everything that you can smell that smells bad is a lie. Those are microorganisms that are living and breathing. If you put them in the freezer, you'll kill them. You'll be able to take the suit out the next day and you'll have a fresh suit. When we ran the hell to where, even though I have a fire suit company, I only had 3 fire suits, 28 races in 31 days, and we weren't going to go out for that every day. We actually learned that trick actually from Dr. Green Ray. He told us about that. It's actually how they kept their BDUs from smelling in the field. They actually had portable freezers and ice chests that would kill the bacteria that way. It absolutely works great, and it doesn't deplete your suit. If you're going to wash your suit, please wash it. Do not dry clean the suit. Dry cleaning is flammable, and not only is it flammable, it has a 21-day incubation period. Plus, they put it in that really nice bag. It holds all of the flammable vapor in that. Have you guys probably seen fires where guys are on fire in a sprint car, especially sprint cars, you see them, and they have this low red glow all over red. Red is a cold fire. Now that sounds crazy, but it's probably 800 or 850 degree fire. What you're seeing, that red glow, is dry cleaning fluid. If you look, it's consistent all over the entire suit. That's dry cleaning fluid. Dry cleaning is the devil. Don't ever do that to your suit. You want to wash it. You need to wash it with a product like our Velocity Suit Wash. It's actually used by NC State. It's actually what they use in the burn lab, so we just have it mass produced for us. Or there are a couple of other products out there that are specifically for cleaning FR carpets. They have no dyes, no perfumes, or anything. What's wrong with using Tide or Gain or All or Downy or something like that? The biggest problem is they have fabric softeners in them. They do feel good, they look nice, they feel well, they smell nice. The problem is the perfumes are flammable, and softening the fabric breaks down the tensile strength of the FR. You don't want to break down that tensile strength because it allows fire to impermeate that should that happen. So clean it with a reputable suit wash, turn it inside out, zip it up, close all the Velcro, always hang it to air dry. No dry cleaning, no dry. That'll make your suit last for a really long time. And don't forget the freezer trick also. I use it weekly for my suit. Right, what do we got next? When and why replace? So we recommend replacing fire suits every 2 years. And I know you guys think that's just when you make more money, but it's actually not. When the suit wears thin, as we just discussed about the wash and care procedure, once the suit wears thin in those areas, it loses protection. It's going to happen mostly in the seat, the hips, and the shoulder area, because that's where we make contact with our full containment seat. Also where the belts come down, also where our hybrid or Hans comes down, all these areas are being sanded against all the time and eventually wears thin. So we call it 2 years, which for a dirt racer is probably going to be somewhere between 75 and 125 shows. For an asphalt racer, it's probably going to be closer to 4 years because pavement guys just don't get as many opportunities. And honestly, you're behind the windshield, it's not as hard on your suit. You also, if you can hold it up and you can see light through certain areas, time to get rid of it. How about if you're exposed to fire? The very first thing that will happen to Nomex, and the way that you can tell it's genuine Nomex is, if it's exposed to fire but doesn't burn through, it will turn a tan, taupe, or kind of like a low goldy orange color. That means the dye has burned out. The first layer of protection is gone, and you should absolutely replace that driving suit. A second exposure could be terminal or critical failure. Once that material becomes brittle, it's very easy to break that barrier and turn that suit into something that could potentially not protect you in the next case. So that's basically our recommendation, and SFI, that's why we're always looking for manufacturer dates. We're looking for roughly 2 years, and then tech guys will start looking around and go, okay, your suit's 3 years old and still looks good, they give you a thumbs up, that kind of thing. But ultimately, we don't want holes in it, we don't want to see discoloration, we don't want to see it filter. Brian, what do we have next? Okay, so the two things that we're looking at at with SFI is thermal penetration and thermal shrinkage. And these are a little bit, I don't know, they're kind of like mysteries for folks that don't study it all the time. As you guys can tell, I'm an FR geek. I'm involved in this every day, all the time. I love to study the science of fire. So the first thing we talk about is thermal penetration. What does that really mean? So SFI uses a 1 watt at 1 meter, 1800 degree whole 3 meter setup, blah, blah, blah. Basically what they're trying to do is they basically use a substance similar to bacon. They're trying to figure out how long it would take for you to receive a second degree burn. And the reason that they're doing this is we want to know what the level of protection is. So TPP is based on a 0 to 100 scale. Most of the suits that you see that are SFI 328-5 are going to receive a 10.8 or higher thermal penetration rating. Well, what does that mean? That means 10.8 seconds before you would potentially receive a second degree burn. Is that a set and fast number? Absolutely not. Because what SFI doesn't do is they don't test with variables or accelerants. So fires don't randomly happen. You guys have been at racetracks your whole life. You've never been going through the pits and seen a guy spontaneously combust. If his race car's not on fire, he's not on fire. What causes fire? Oil, gas, transmission fluid, power steering fluid, rear end grease. These are accelerants. Unfortunately, there's no way to test with all accelerants to give TPP ratings for every situation. So it is a dry burn with a Bunsen burner, alcohol base, 1 watt, 1 meter, 1800 degrees, bam. How long does it take for thermal penetration? That thermal penetration number gives you the rating, and it's going to be somewhere between 10.8 seconds and whatever. That turns over to a TPP rating of somewhere in the 19.2, 21, 24, 27. I think the highest TPP rating that I've ever seen is like a 28.2 or a 28.4. It was not my company. It was actually the guys from Stand at 21 out of France, and that's their $10,000 marquee mock suit. I think our current highest rating on our crew suit is 27.6. To the best of my knowledge, we have the highest rating that is manufactured. Part of that is we pedigree our fabrics. We don't import fabrics. Our fabrics are domestically manufactured in Tennessee, and we only use genuine DuPont Nomex spun thread to make sure our TPP ratings are high and they're also consistent. The next part of thermal is thermal shrinkage. There are plenty of fabrics that will give you a very high thermal penetration rating. They won't burn through, but unfortunately, like shrink wrap, they shrink up. Thermal shrinkage is the devil. If thermal shrinkage comes, then you have all of that heat compressed against the skin. Now we can't actually get that pulled off the skin and stuck to you, which makes for terrible infection and lots of bad stuff. I think Brian has some photographs of a suit that a guy was wearing. Not a bad suit, but it was an old suit. Hadn't been cared for properly, hadn't been cleaned. It was a dirty suit. He got burned. Terrible burns. It's life-changing, guys. It's life-changing. We're talking about somewhere between $500 and $1,500 a year will keep you completely covered, or you can have a miserable life. Why would you not make that choice and do it every year? But hey, we understand times are tight. So thermal penetration, how long it takes to burn through, thermal shrinkage, how quickly it shrinks up. Brian, what else we got? Types of FR. So would you guys believe me if I told you that nobody on earth makes a fireproof suit? Not even me. My family's been doing FR since 1954. We are perceivably the oldest manufacturer on the road. But guess what? We've never built anything fireproof. Did you know that even rocks will burn if you get them hot enough? That's what happened to Hawaii. They're called volcanoes. Everything burns at some temperature. There are 3 types of FR. The very first thing that we deal with is going to be durably fire retardant. And what durability and fire retardant mean are rocks, earth, sticks, trees, things that are found in nature that inherently don't burn, have a low flash point and have to have a high acceleration point in order to burn. So those are things that are durably fire retardant. The only thing that we borrow from the durably fire retardant industry is going to be a product called linting. Linting comes from beechwood, and that's what we make our underwear out of. Actually, we make it, and so does Perry at PXP. We use a linting derivative because it has a low flash point and a very high incineration point. That's durability. So wood, sticks, rocks, trees, mud, those things are all durably fire retardant. Inherently fire retardant is going to be all of your arrogance and your Novexes, things like this. This means that the chemical makeup of this product does not allow it to actually burn at lower temperatures. Of course, it will eventually incinerate, it will eventually burn, but it has a very low flash point, which means you can't just strike a match to it. And it has a very, very long durability or incineration point, which means it'll burn for a long time before it actually fails. So that's going to be your air mitts. And most fire suits are air mitts. Most fire suits are not Nomex. People assume that they are. Nomex is extremely expensive. And most of your low-cost manufacturers, these ads you see pop up on social media all the time, and I don't want to call names, but like Fit, Furbo, that one group from the Northeast just got decertified. Those are air mitt suits. That's cheap FR, barely better than cotton. It only passes the test one time. It's not a multiple durability suit. The Nomex 3 and Nomex 4 fibers are premium. It's the best stuff that you can buy. It lasts, it washes, it's durable, inherently fire retardant for a period of time. The next thing is topically fire retardant. And I think you guys have recently seen one of the guys, the sprint car guys, is pushing a spray that you spray on your suit to make it more fire retardant. Does it work? It does if it's used correctly. Here's the problem. Most people don't use it correctly. It needs 48 hours to cure. Most people don't think about it 2 days ahead. It's the same thing that you can buy off of Amazon that you spray on movie theater curtains. Movie theater curtains are FR. A lot of folks don't know that. They have to be fire retardant in the event of a fire. That's topical spray. You guys remember the old days, the FR cotton coveralls that we wore back in the day? Vanox, Pro-Van, those kind of things. Now, there are some impregnated cottons now that are really good, but anything that's sprayed is going to have a wearability. Meaning, as soon as it receives abrasion, like from seatbelts, that area is gone. As soon as it's washed, that area is gone. As soon as it's dried, that area is gone. It's a reapplication process. Not that it is bad, but it is a minuscule layer of protection. And we've not seen a case so far where that little bit of protection made any difference whatsoever. Durably, inherently, and topically fire retardant. Those are the three types of FRs we have. Brian? Okay, embroidery and decoration. We constantly get asked, hey, I want a suit like the NASCAR drivers have that have like the cold sticker looking deal on it. Well, the stickers can go on there, but the problem with the stickers are, and they are fire retardant. Unfortunately, you can't wash them. Everybody says hog wash, you can wash these, you can. But unfortunately, the sticker, the color comes out of it. If you'll think about it, you've never seen a NASCAR driver wear the same suit 2 weekends in a row. They don't. In fact, most drivers have 2 to 3 suits per weekend to make sure that all the sponsors look good. Obviously, they're working on a 10, 12, 15, $30 million budget. It's not a problem. So we err and default towards embroidery. Keep in mind that with embroidery is inherently fire retardant. There are 4 parts to the fire tetrahedron. If you can remove any of the 4 parts, you don't have fire. Air, fuel, oxygen, chemical reaction. Well, if you can remove any of those pieces from it, we remove air because embroidery is so intense. If you put a fire suit in a commercial incinerator and you left it at 5,000 degrees and went to lunch and came back, the only thing that would be left would be the embroidery and the teeth of the brass zipper. Those areas inherently won't burn because you can't get air or oxygen into them. Decoration or the flash work, those are just going to be additional layers of the suit that are put on it for decoration, flash work, and those kind of things. They are made from the same exact fabric. We have seen some companies, we won't call his name, but there's a company in Texas that is now screen printing fire suits. Screen printing, like I have on my shirt, like you probably wearing on your shirt today, is plastisol. That is an accelerant. That suit does have an SFI label on it. In your mind, you're safe and you're great. Unfortunately, that is way far out of the program, and multiple companies have called this company out about doing that, but he hasn't been caught yet. So be careful. Do not get a suit that has screen printing on it. Screen printing is flammable. It will melt. It is an accelerant. It will go into the garment, and it can cause you lots and lots of trouble should you ever have a face fire. And I tell people all the time, the best part of my job is less than 1% of racers will ever experience catastrophic fire. That's the best part of my job. The worst part of my job is only 1% of racers will ever experience catastrophic fire. Everybody's chasing pretty. Very few people are chasing safe until it happens to them. Brian, what do we have next? Why do drivers get burned? Man, this is a great big topic. A lot of people have theories, a lot of people have ideas, a lot of them got burned. But the truth is, most people just don't know. We talked a little earlier about fire signs and about sweat signs. If I can keep you dry, chances are I can reduce your chances of being burned by 70 to 80%. Dry skin doesn't burn. The reason dry skin doesn't burn is it doesn't allow it to sizzle. Sizzle is what gets us in trouble. But what causes fires? Engine explosions, fuel cell explosions, being splashed with fuel, being splashed with power steering fluid, transmission fluid, being splashed with any of those things. Those are the things that cause our drivers to get hurt. Not washing the suit, not caring for the suit, not wearing the correct type of suit. We absolutely recommend underwear. Layers are your friend, and it's not the layer is your friend, which it is, but the air between the layers actually absorbs that heat energy. And if we can absorb that heat energy, we can keep you from being burned. So all of your hot fluids obviously can ignite and burn you. Fire color, white fire or clear fire is the hottest. That's definitely on fire. We can only see it because of the trash it's being burned with, partly. The colder the fire, the less likely it is for penetration, the quicker we can get it put out. And even though you may have 10, 11, 12 seconds per rating, how long will it take for the safety crew to get there? So make sure that you're wearing all the protection, clean protection that you can every single time, and that you've got all of your fluids and everything sealed up well so you're not covered in fluid in the event of an accident. But drivers get burned because of thermal penetration and mostly because of the physical factor. Wear base layer underwear so that it can absorb the sweat. Wear a suit that has a moisture wicking liner also to pull the sweat further away, and it will give you a much better chance in case of fire. Brian? Takeaways. So first and foremost, I really want you to encourage guys to look at that SFI website. There's lots of things that are going on now. It's preseason. We're all buying fire suits. Everybody's looking for their next thing, and everybody wants a deal. Hey, man, I want a deal too. But here's the thing: is your life worth saving $2, $3, $4, $500? Is your life worth saving $10,000? The answer is no. The average cost of a fuel today is $8,347. That's actually on Google. I looked it up this morning. The average cost to treat a 1-inch cube skin graft from a third-degree burn is $34,000. The most expensive suit that I have is $16.99. Look at the money that I just saved you, and I kept you safe. Not just me, but all of us. But do your research. If it's not listed on the SFI Foundation website, don't buy it, don't buy it, don't buy it. Don't fall for the sales pitch. Don't fall for the lie. Don't take the chance. This is your life. It does not matter what anybody tells you. I don't care if your best friend is selling it. I don't care if your pastor is selling it. Have they flown to Pakistan, Vietnam, Sri Lanka, Laos, or wherever the crap was made, pedigreed what it was, pedigreed the material, seen the people, worn one of the suits themselves and set themselves on fire? Absolutely not. And if they haven't, you better not put your blood in it either. SFI Foundation, 3.2, click on manufacturer, scroll down. If the manufacturer that you want to use is not listed by name, and if they tell you somebody built our suits, this company built our suits, bull crap. I'm Michael Jordan's twin brother. Prove to me that I'm not. I'm not, right? You can't prove it though because I said that I was. Absolutely don't buy anything from a manufacturer. It's $800 to get SFI certified. You really want to trust your life with a company that doesn't have $800 for fire testing? You're a fool, and I'll tell you to your face. Make sure that that company is on the SFI website. Number 2, wash it, clean it, care for it. Keep it out of sunlight. Put it up when you're not using it. Hang it up. Let it air dry. Use the freezer technique to preserve it. Only wash it with premium cleaners. Check all of your fittings. Check everything in your cockpit. One of the things that I want you to make sure that you do is I want you to practice getting out of your race car all 4 sides. If you ever get a chance to see our other friends, not this Brian, but Brian with Speedway, they actually have a rollover simulator. They want you to practice getting out of the car upside down. You see those guys in the trade show, it looks a little bit funny, go over there and do it. Practice getting out of all 4 sides. Practice getting out of all 4 sides of your car. Do it once a week until you get incredibly good. You never know if you're going to be getting up against the wall with a race car on top of it, and your car could be on fire. I can't think of a worse possible way to die. Do your part to make sure that you're safe and that you can get out quickly, safely, and you know where everything is. You're going to be disoriented, we understand, but make sure. Practice it in the dark. Practice it with your eyes closed. You need to know your way around that race car in all circumstances and all situations. And don't think it's never going to happen to me. You're the guy that needs to be doing it every single day. If you'd like to find out more about fire safety, talk about your fire suit, or you'd like to learn more about Velocita, we're super easy to find. I'm sure you guys have seen us on social media, but of course our website is velocita-usa.com. The office number is 336-764-8502. Justin is our suit specialist in-house at 336-829-0654. You can reach me personally. Yes, I'm the president. I'm the owner. I own Velocita Lock, Stock, and Barrel. I have since 2009. It's the same company that started in 1954 with my grandfather. You can reach me at 336-816-7223. That really is my number. Call me and text me. We would love to talk about it. If you feel like I'm one of the companies that called out today, if you got beef with something that I said, call me. We'll talk about it, and I'll prove to you everything that I said is 100% accurate. Don't take my word for it. Go to the SF5 Foundation website. Do your research yourself. Brian Littleton, you're a scholar and gentleman. We really appreciate you putting the safety seminar on. This is great information for everybody. Unfortunately, I've been sick and bad. I didn't get to hear everything that is there. I know you're doing awesome work for everybody out there trying to keep people safe. And to the best of my knowledge, Brian's receiving zero compensation for this. So, man, this is awesome. Really appreciate what you guys are doing. I hope the weather holds out for a great show here this weekend. Thank you, Brian.
Appreciate Brad being on. I know it's kind of a little different for me had to do that, but he is available. I don't think anybody wants to see my beef order there, my personal job. But we're going to get Mr. Patrick Moore in the back to come up, and he's going to kind of fall right into this, and then Chad will get you on. I know that's probably hit home to you pretty hard right there. There you go. There you go. He's got one.
Yeah. Okay. While they're setting up, let me ask a couple questions if I can. How many of you are involved in any portion of the emergency response in any of the facilities that you work at? Fire, EMS, fire, medical, okay. Promoters and sanctioning bodies, anybody? Okay. This is that, I just wanted to kind of survey. So a lot of what the focus has been, I just met Brian an hour ago. This is that, I'm the chairman of the NFPA, the National Fire Protection Association's Motorsports and Safety document, is that we're going to go through a little bit of helping you. What I'm going to urge more than anything else, if you're a racer, if you're a purebred racer, is that when you come through the back gate and you sign your life away, although I'm married to an attorney, I want you to never believe that's true, is that do you look for a fire truck or an ambulance? Do you actually take a look? I know your primary goal is to race and possibly win, but do you look at any of the emergency services that are at the facilities and all the different facilities you go to? Okay, go to ICMS, right there, and go right there. And start the slideshow. Go up to slideshow. Right there. Should say from the beginning. There you go. All right. Oh, great, great, thank you. So this is, anybody in the contracting business build homes, anything? All right. Where has your experience with the National Fire Protection Association come in the past?
Fire door inspections, sprinkler systems, trips, alarms.
National Electric Code, right? Things of this nature.
Yes.
So what the hell is the NFPA doing in my race business? That's the first question I always get, and where this document came about. Is that Marion County, Florida, in the 1990s, the code enforcement official found the fuel tanks underneath the grandstands, and he actually couldn't find the facility because he couldn't find a code, and that's where the petitioning began over almost 30 years ago. And that's where that comes from. Let's see. Well, there we go. Every 5 years, the NFPA and the group, and I'll explain the committee here in a couple of minutes, is that puts out a document for assisting in the safe operations of emergency services at a racing facility. Here's an example of 5 years ago and 10 years ago, what that looks like. What the hell am I doing here? I just completed my 35th Indy 500. I worked on track as an extrication guy in every form of motorsports, F1, all right, on down, and have got dirt in my beer at a Saturday night bull ring also. I know a lot of times people are like, oh, well, you guys at Indy, you've got more money than God. We have Roger Penske's money, so we have God's money, all right? But it is that it's about scalability to help you no matter what. The truth is my real job is I'm the Chief of Special Operations in Knox County, Knoxville. I've got 40 fire stations that I'm running every day throughout Knox County. I drove over. This is the first time I've gone on the other side of 40. Is that I've spent a whole lot of time in the 16 Tennessee counties that were affected by the hurricane, but I didn't come over to the North Carolina side. So I literally drove 45 minutes north to drive 45 minutes south for the 4 miles I couldn't cross to get here. The devastation, though, is just as much on the North Carolina side as it was on the Tennessee side. But that's, what I'm doing every day. This is the team that I'm on. And what happens. But it is not uncommon. Young lady, can I pick on you, but actually just highlight you? Where do you work? Volusia in Florida. Okay. Volusia's been around a little while. What is the staffing like on a normal event? 1 fire truck, 2?
Yeah, So we have a fire truck with 2 firefighters and then a paramedic and me on the position.
Okay, a paramedic.
And then, we have, an ambulance that Volusia owns that has another paramedic in it. And
Great.
the paramedic and me ride in like a side by side.
Okay. How many of you guys actually take a look at the ambulance at the facility you race in? The seatbelter guys going like, nobody looks, right? You do, good. All right. First thing I want to tell you in comparison, because people are going to tell me, well, who's going to pay for that? Do you know that anywhere in the United States that Pop Warner football requires a paramedic? Okay, plain and simple. Okay, parents win. Where's the guy that was, the hockey guy left, all right, is that, so the whole kind of finality of saying there's no money for emergency services at the Saturday Night Bull Ring is BS, okay? And where it's BS more than anything is that you're gonna find out the first time you have a real incident, all right, where the legalese comes from. NFPA is the guidelines that goes right forward to OSHA, is that, and if you have never had a discussion with ownership at a track, for example, is what to do if there's a death on the property. That's a horrible thing to think about. I know that, all right? But if you're in racing, and if you've been in racing for any amount of time, is you've been around the facility and have seen something serious happen, all right? Thank you. Is Volusia in Volusia County? What county is it in?
It's in Deland.
Okay. All right, so the medical examiner or the coroner, are they allowed to move the body? That's a good question, isn't it? Oh, look, guy's shaking his head back there.
I got it.
Okay. How do they get around it then? Do you know? Have you ever heard the description, no one ever dies at the track? I will tell you, all right, I'm not speaking out of turn, is that no one ever died at the Indianapolis Motor Speedway. Where do they die? Excuse me, racer, I need to be corrected. All right? They die at Methodist Hospital. We transport them. All right? Now, emergency services, and the reason I put that asterisk on there is 3 times in the last 10 years, we've had deaths on the facility, all right, that were actually CO2 deaths in RVs overnight. All right, just get found the next morning. Is that, are you allowed to move the body? Okay, so these are some of the emergency services things that I know generally a racer might not, 100%, and I'm going to come back to the fire trucks and the EMS in a second, but it is that they're required by law, and the law is going to be looking for you, all right, for your involvement. So where this comes from, where NFPA 610, all right, is scalability. This is my favorite speedway, all right, because they have a great logo on the side of their safety trucks. Dog Hollow is in PA. It's a Saturday night bull ring, all right. Its average crowd is about 400, all right. It's a fun place to go to, all right. If you're a fan, what are you looking for? Dirt in your beard, right? The scalability of my team to their team, all right, has been thought about. And where I want to, put you into place is that my friend here, right here, how long you been racing? 40, right? Okay. This is that, do you remember the first time you saw the safer barrier at Indy? Okay. Not exactly, but but I mean on TVs.
Oh, yeah.
Okay.
No, I don't know.
All right, but you went, wow, that's going to save some lives. What's going on in the state of North Carolina right now, literally today, that's shocking about the safer barrier? Anybody know? They're putting the safer barrier in at Bowman Gray for the All-Star race. I don't know exactly the size, but I know it's much smaller than a 1 mile, right? Is that affordability and in regards to safety. Is there anybody here racing today not wearing a Hans or a hybrid? Over the past 20 years, cost, all right, R&D, is that we've proven where things go, is the trickle down effect. So yes, there's been rules and regulations for more than 30 years, but they're moving towards, okay, affordability, Saturday night bull rings, and how a simple 2-man fire truck crew and a 2-man ambulance crew, all right, can actually prepare and be very good at their job. The guy that was on earlier that talked about how drivers get burned, all right, is that the second way is how about we put out the fire, all right, how about we put out the fire? So, safer barrier moves forward. I want to just show you a little bit internally, is that, what the hell is the guy from Indy talking about? Here's an example, all right? Chapter 5 is on training. This is that, what are the expectations from the guy in the flag stand, to the guy at the back gate, to the 2 guys on the fire truck, to the 2, and I should say guys, 2 people, 2 staffers, to the people in EMS. Here's scalability, all right? This is that from awareness to operations to technician to specialist, how much training you should have. State of North Carolina has a fire academy level program for emergency services responders. All right, so where do I get my guys trained? Cross-referencing that. All right. The other is PPE. So a lot of guys are going to say, well, the track I race at, the guys are wearing their fire gear from the fire department. Not unusual at all. One of the things that NFPA did, and his name, Brad talked about TPP. TPP is a thermal test, and it came not originally to the fire suit guys. It came from fire gear. All right. There's been a cross-reference to what kind of gear is needed, and the truth is that to equal an FR, all right, a 3.2.5/5. Is that you can wear wildland gear, all right? So there's an equivalency, all right? So the Saturday night bull ring, that is not going to go out and buy fancy suits with embroidery on it, like I get to wear, but there's fire gear, and what we're asking is that I really would like you to not be in a pair of Carhartts, okay, with an LL Bean Woolrich, okay, shirt on, is that how about we think about it a little bit? How about we think about it a little bit? Is that those comparisons and what will insulate you. And as I said before, and I'll repeat, is that you're not going to find out how much trouble you're going to be in until the day after, all right? Unless you do some pre-planning, all right? And pre-planning doesn't necessarily cost money. Pre-planning is guidance. These documents are out there for you to take a look at, and I'll go to the next one. Here's an example of what's in the book. I'm going to show you a series of these. These are checklisted guideline sheets for you to prepare ahead of time with scalability. You can see here, column 1, column 2, column 3. This is that the size of your track, the size of your audience, the speed, okay, the races are going on. Do you have a set of jaws of life there? All right. Do you have a paramedic on board? If the track's more than a mile, maybe you should have 2 fire trucks. That scalability, all right, and affordability to the ownership. The promoters and the sanctioning bodies is in, okay, these simple checklists you can see. Check marks and boxes, all right? They're great questions to ask ahead of time to what's going on. Emergency action plan. It can be as simple as this. How many of you, all right, at some point in your life have been to Disney? What did they do when you pulled in the parking lot to help you out? All right? They made you remember where you parked because, well, there's a hell of a lot of cars parking there. And how did they do that? Well, they got you to think of some character, whether you were in Mickey 23, okay, or Daffy 69. So when you came back out 12 hours later, you went, oh, I remember where we parked. Same thing, all right? If I go to Volusia County, how big and how many parking lots are there? I'm picking on you, but just one big parking lot. But if a guy's having chest pains in a blue Ford Taurus and you dialed 911, is it possible that I can have somebody there in the area pretty quickly but have trouble finding it? Directions. If you would actually just take the light poles, all right? And let's appeal to motorsports fans. And you're in Allison 27, or Petty 3, or Earnhardt 5, all right, to some markings. Would we be able to find the guy having chest pains in the Taurus a little faster? All right, just some simple guidance, all right? Hell, sell the signs off, okay? Let Waste Management put them up, all right? Or anybody else that's sponsorship at your track, Serve Pro, all right? There's a variety of people at different places that buy sponsorship. Let them print the signs, all right? But help you out for your emergency services, all right? Put things together. Again, these are right off of the emergency action plans. The next one. We never had bad weather come up on a racetrack at night. Happens all the time. All right. What's the actual promoter got to worry about? Geez, if I send them back out the gate for the protection of their car, will they come back in when it passes over a half hour later? Okay. This is that a pre-prepared announcement that says exactly, all right, ladies and gentlemen, please go to your cars for safety. This is that we'll make a decision within 20 minutes of whether we're going to open back up or close, and your ticket is good next week if you want to go home. Put it in the announcer's box, all right? Do you have a plan? Seek shelter. These are the National Weather Service has a planning mechanism that will actually pay for these things, all right? Do you have radar and lightning, okay, in the press box? Just some things. Again, I know that your general audience is about building cars and racing, but is that these are some things that we want people to think about. All right, that planning ahead can work for you. What do I need on my fire truck? What kind of things should I prepare for? This is that, again, a checklist that somebody's done for you that is OSHA compliant, all right, to you figuring out what's going on, all right? Anybody have any questions? All right. The next thing I want to talk to you a little bit about is what's coming down the pike. Is that racers would never do anything to go faster, would they? Huh? The evolution of the battery power is coming. And what's phenomenal, and I'm going to show you a video here in a second of why it's really gotten closer than you think. I know that generally, if I said something to you about a hybrid race car, you might first think about this, okay? IMSA's EV hybrid, okay, the Penske Porsche, really nice car, great championship last year. But this is what you probably haven't thought about. Now, I'm going to see if this is going to work. Can you tap on the video? Oh, there we go, great. That's an NHR junior dragster, okay, with a lithium-ion battery in it, all right? That was a car invented for a less than 16-year-old. They're allowed to race up to 18 years old. I don't know if anybody's got any experience, but you guys are mechanical guys. That is rocket fuel. There's no PPE in the world for you to withstand dealing with that. None. Okay? Not an aircraft fire rescue suit. This is that, do you have a plan? That melted the frame in 37 seconds at an 1/8 mile little track. Go ahead and tap on the second video. You can have all the water you want. You might cool it, all right? But thermal runaway in an EV battery, all right, is only going to be buried into the ground, all right? The owner actually took their excavator, and that's exactly what he did. Thank God the car came off their escape road and wasn't right on track, because it'll melt the asphalt. I did not know, and I mean, I can get around a lot of motorsports. I'm lucky enough to have been, in the industry quite a while. Is that we were looking at junior dragsters with EV lithium-ion batteries in them already in the year 2024. So, funded to the, is that we're commissioning a new research group, 32 people from all the sanctioning bodies, manufacturers, Tesla on down, all right, our research group for what we're gonna be doing, all right, for EV fires and emergency services. Key thing is gonna be the construction of the car. This is what IMSA did, is that we won't see thermal runaway if we don't have a battery box that's been destroyed, all right? But batteries, integrity is, we don't know. We never thought that we'd see a G-force hit over 100 Gs, and we've seen it several times. So those things are coming about. That's what's next. I will tell you, uniqueness of coming here and finding O'Brien is that the national gathering, what is traditionally every year, is called the Safety Summit. It used to be at Concord, but now it's moving to Daytona. Actually, I'm headed there Saturday, depending on the snow. But the first gathering of the professionals that are going to be looking at research for electric vehicles, hybrid, battery-powered things, kicks off on Wednesday. So there's people doing national research, government-funded research. Yes, there's rules. Yes, you can get in trouble, but there's help available, all right, to emergency responders at racetracks. There's several organizations out there that can help with what's going on. There's scalability to the smallest place. You can see, from like the turnout gear, the comparison to the Saturday night dirt track to just your local level fire department is to how you get things figured out. But I'm going to go back to my original thing, and that is on Saturday night when you pull in the back gates, all right, and you take a look. Take a look at the emergency setups at a track, ask a few questions, all right, and start to check things out a little bit. Are they really prepared? A van with red lights, okay, with a red cross on it doesn't mean, okay, that they're ready, all right? A lot of facilities have bought old used ambulances, an old fire truck, all right? They're probably wetting the clay down so the racing surface is good versus are they prepared to put out a fire? Take a look at your emergency services organization, what's going on there, not as a critic, all right, trying to help them. There's lots of help with a variety of different organizations around the country. That I don't know how to make your car go faster. I will tell you that. And I've seen some pretty fast stuff, okay, at 16th in Georgetown in my lifetime. But what I have seen is I've worked in every scenario I think that comes about. And more than anything is we want to help the smaller places because statistically, all right, that's, where the deaths are coming from. A lot of times, how things happen is that we see horrible ESPN videos about fires, 20 guys running up with fire extinguishers wearing flip-flops and shorts, things of that nature. We want to make the business a little bit better for race car drivers, the teams, all right, and the facilities. So that's my presentation. I hope that helped a little bit. Is that I'd be happy to field any questions that anybody has. Should be one right there. You can scan that QR code, get my email address. I love to hear about things that are going on. I'll be happy to help you out, send you copies of those forms. They're free, not a problem. Whatever we can do to help out, I'd be happy to do so.
You just answered my question. I was looking at the 610 guide on the NFPA website. They charge like $200 for the entire guidebook.
I think 157. It's not cheap.
And then they got, they got a subscription model out there too. I just want to make the public aware of that. You don't have to necessarily buy the entire book. You can subscribe and look at it, get the information you need, and then go back. But the book itself, you're talking, you say yourself, statistically speaking, the most of the racetracks, we see the most likelihood of incident are the small mom and pop operations. being the race community as it is, I mean, it could, we can coordinate with Brian or something, maybe get them that information, either in a digital format or something, to try to help facilitate them, because they're not going to seek out this information, and that's a reality of just, the type of ownership that happens in these small
We're 4 hours back to the up here for 20 minutes.
of our systems so that you can move the whole system up or down on you inside the cockpit without having to remove one of the pieces. Even with our ratcheting system, we still generally put a adjuster on this side so that if you were in that situation where you had two drivers, you can adjust that side down a little bit or up a little bit without having to, like when I was racing, to take the seat out and to adjust that without that adjustment.